Do you know Java and want to build your first Spring Boot web app, but you don't know where to start? Well, in this video, I'll show you how to build a task app using Java and Spring Boot, how to use the Apache Maven build tool, and I'll explain the Spring Boot theory that you need to know to pull it all off. I'm Aaron Bourne. I've been coding for over a decade and a half, and in that time, I've built apps for startups and the enterprise. And now I teach the same skills that I use professionally, so you too can build professional-grade Spring Boot apps. Before we go any further, check out the link in the description below to download the accompanying book for this build for free. In it, you'll find the app source code, requirements, and a comprehensive write-up of this build. It's everything that you need to follow along with this video. Now let's cover what you need to know and the tools that you'll need to get the most out of this build. As for skills, you'll need to know the Java programming language and you'll need to know it well. Ideally, you've used it for a few years professionally to write tests or to build things other than Spring Boot web apps. You'll need JDK version 25 installed to follow along with this build. As for IDEs, I'll be using IntelliJ IDEA, the community version that you can download for free on the JetBrains website. If you have the Ultimate Edition, that will work too, but you don't need to purchase an IDE for this build. The Community Edition will work perfectly fine. To run the user interface that I'll provide you, you'll need Docker installed and you'll need to know the basics of how to use it. You can find all the information that you need over on the Docker website. Now, a quick note on coding style. I'll be coding using my interpretation of clean coding. It won't be the most concise code, nor will it be the cleverest, because quite frankly, that's not how you win at professional software development. If you're against writing clean code for whatever reason, you'll find plenty of other resources right here on YouTube, which will suit you better. Happy searching and no hard feelings. The final thing before we start, the Devtiro approach. I value your time, so I'm not going to waste it by reading the docs to you. Instead, we'll focus on what I believe to be the most important 20% that gets you 80% of the results. If you're paying attention to this build, you will have questions along the way. The place to ask them is over on the Devtiro Discord server. You'll find the link and the instructions on how to join in the free book, link in the description. All right, with that covered, let's get started. So what does our app need to do? Well, let's explore this build's requirements. So here's what we have coming up in this lesson. I'm going to take you through the 10,000-foot view of this build. We're then going to ask the question, what is a user story? Before then going through the task app user stories. So let's get started then with the 10,000-foot view of this build. At a high level, we're going to be building a task app, which is an application that allows a user to track the tasks that they hope to complete in future. You'll often hear these referred to as to-do apps or reminder apps. The premise is pretty simple. We can create a task like this. We can give the task a title, perhaps walk the dog. We can give it an optional description, such as Rex needs a walk. And then we can select a due date, so a date that we hope to complete this task by. So let's choose, for example, I don't know, the 29th of November. And then we can set a priority. Is it high priority, medium priority, or low priority to take Rex for a walk? Well, let's go with high priority in this case, and then we can create that task. And now we have our task here, walk the dog, that we can then complete in future. When we complete that, when we have taken Rex for a walk, we can click this here, and then we can see here that you have one completed task, and we have a green tick next to walk the dog. Regardless of the actual task, the goal is always the same. We want to capture the task so we can remember to do it later, and then actually complete the task. But of course, this is all very high level. So how do we capture the actual requirement of this build? So next, we're going to answer the question, what is a user story? To capture the requirements of this build, we're going to use a technique called user stories. This is a simple but powerful technique that you'll often see used in agile teams. Now, variations on this approach do exist, but this is the Devtiro one. Each user story has a title, which summarizes the purpose of the story. In this case, it might be create a task. To further help identify user stories, Devtiro user stories use this prefix. We can see here TA01, create a task, where TA stands for task app, and 01, the first user story of this build. So we know this user story is about creating a task, but what about this 3-sentence structure? We have, as a productive person, I want to quickly add a new task so that I don't forget what to do later. You'll see this 3-sentence structure with all user stories, and it tells us a lot. It tells us who, in this case, a productive person. It tells you what they want to do, so what, in this case, to quickly add a new task, and then it tells you why they want to do that. in this case so they don't forget what to do later. Now you might be familiar with a more traditional requirement such as this: a system shall capture a user's tasks. Requirements like this, they tell us what needs to happen, so we need to capture the user's tasks. But it doesn't tell us very much about the who or why they want to do that, which is why there's more value in user stories in my opinion, and it's why you'll see them used on Devtiro builds. But that's not everything. Each user story will have a set of acceptance criteria, and these are statements which can either be true or false. And the idea is they'll start off as false at the beginning of the build, and once you've implemented this particular feature that the user story represents, they will all be true. So in this case, a user can create a new task, and each task has a title, optional description, due date, and priority level. Right now we haven't built anything, so both of these statements are false. But once we implement the create task feature, both of these statements should well be true, or at least they should be true for us to consider this feature complete. So whereas the user story in the 3-sentence structure gives you a lot of high-level context, these are a bit more specific, and together they represent the features that we are going to implement for the task app build. So let's now explore the task app's user stories. There are 4 user stories in total for the task app build, and we've already seen the first one. So TA01 is about creating a task. As a productive person, I want to quickly add a new task so that I don't forget what to do later. And the acceptance criteria for this one is a user can create a new task, and each task has a title, optional description, due date, and priority level. So this one about creating a new task. So next we have TA02, update a task. As a productive person, I want to update an existing task so that I can fix mistakes and keep tasks up to date. The acceptance criteria for this one is that users can edit a task's title, description, due date, and priority level. So whereas the previous user story was about creating tasks, this one is about updating an existing task. Next we have TA03, delete a task. As a productive person, I want to delete an existing task so that I can remove tasks I no longer need. And the acceptance criteria for this one is that users can delete tasks. So we now have a feature for creating a task, for updating a task, and now deleting a task. And finally, we have TA04, completing a task, the goal of every task that we create in the first place. So as a productive person, I want to mark a task as complete so that I know which tasks need my attention. And the acceptance criteria for this one is that users can mark open tasks as complete, and users can mark completed tasks as open. So if a user accidentally marks a task as complete, they can undo that change so they can then do that task a bit later and complete it at the appropriate time. And with that, we now have 4 features. We want to be able to create a task, update it if we've made any mistakes, delete it if we no longer need it, and then complete it when we have actually done that task in the real world. And there we go, there are the features for the task app build. We want to be able to create a task, update it if we've made any mistakes, we want to be able to delete it if we no longer need it, and we want to be able to mark it as complete when we've actually completed that task in the real world. So in summary, we've explored the concept of user stories, and we've established the build's requirements as user stories. We've explored the requirements, but let's now see them in action. Let's explore the finished app. So here's what we have coming up in this lesson. We're going to create a task, we're going to update a task, we're going to complete that task, and we're going to then delete the task. So let's get started and create a task. So here we are on the user interface. Don't worry, I'll show you how you can run this locally a little bit later in the build. For the minute, we're just going to explore what it can do. So we're going to create a task to begin with. So I'm going to click on this create task button here, and this brings up a modal or a dialogue where we can fill in some information about the task. So let's go with walk the dog, and then we can go with a description, which in this case might be Rex needs a walk. And then we have a due date that we can select. It brings up this calendar for us. So let's go with, I don't know, the 10th of December as the due date. And then we can select a priority level, high, medium, and low, defaulting to medium. Let's go with high priority. And if we click on the create task button now, we can see that a task has been created here. So walk the dog, Rex needs a walk. And there we go, we've just created a new task. So let's now move on to updating a task. we can update an existing task by clicking this button here. We can see it brings up a modal, a dialog, just like creating a task, but this one already has information in there. Walk the dog, Rex needs a walk. We can update this. So we can go with walk the fish, and then we can go with Frank needs a walk. We can change the due date if we wanted to. Maybe we can change the priority. And when we edit a task, we can also edit the status of the task. This is currently open. We can set it to be complete if we choose, but we'll also see there's another way of doing this as well. So we're just going to leave it as open. And if we click on save changes, there we go. We can see the task has been updated. Walk the fish, Frank needs a walk. This is low priority, and we've changed the due date. And there we go. That's how we update a task. So let's now explore how to complete a task. So we've already seen one way of how to complete a task. We can edit a task and then we can select a different status, which in this case might be complete, saving changes, and the task gets a little tick next to it. That's one way of doing things. If we were to edit again and then change the status to be open once more, there is a much easier way, which is a bit more intuitive, which is to click the checkbox icon next to the task. And there we go. We can see that task has now become complete and the number of completed tasks has increased by 1. If we wanted to uncomplete this task for whatever reason, we can click it again. We can see that the completed number has decreased, so it's now 0, and we no longer have a green tick next to this task. And finally, let's see how we can delete a task. You may have already guessed, but to delete a task, we click on this button here. Clicking on this button will bring up another dialog modal. This one asks us, are we sure we want to delete this task? And it cannot be undone. If we choose to delete it, there we go. We can see that we no longer have any tasks here and the counts have all decreased to 0. And that's how we delete a task. So in summary, we've explored each feature that we are to implement. We've seen the project requirements and we've seen the finished app. But what's the first step to go from one to the other? Well, let's explore the applications domain. So here's what we have coming up in this lesson. We're going to ask the question, what is a domain? And then we're going to explore the applications domain. So let's get started and ask the question, what is a domain? When you were learning Java, you likely learned about object-oriented programming, or OOP. In OOP, we model software based on real-world things, or objects. Which objects we use, how we structure them, and how they interact make up our application. We call these objects the application's domain, and we call the process that we go through to work out the domain modeling. Now, different domain modeling techniques do exist. You might use noun-verb analysis, you might use event storming, you might use something else. But there is one truth here. It's more of an art than a science. So to keep things approachable for this build, I'm going to give you the domain that I've come up with. So let's now explore the application's domain. You don't need a fancy technique to tell you that a task app needs an object to model a task. What's not so obvious is the state and the behavior this task object must have in order to make our task app work as it should do. So we're going to start with the task class to model the task concept in our domain. For this exercise, we're going to focus on the state or the fields the task class must have. And from this, we're going to learn how to structure our data. Modeling the behavior or the task class's methods is less important at this stage. We'll see a bit later that it's typical to separate the state and the behavior in a Spring Boot application, so they often don't exist in the same class. So let's now ask the question, what state, what fields does our task class need? If we refer back to the project brief to the user stories, we learnt that a task must have a title and optional description. Both of these things are text data, so we're going to represent them as the string type, and we've called them here title and description respectively. Also mentioned in the project brief is that a task can have a due date, and we're going to use the local date type to capture this information. So what's the goal of every task? Well, it's to go from not complete to complete. Now we could use a Boolean to capture this information, where false is not complete and true is complete. However, if we wanted to add another state a bit later, such as an archived state or an in progress state, a Boolean makes that sort of difficult. So in this case, we're going to use an enum. We can see here the task status enum currently has the values of open and complete, the two states that our task can currently be in. If we wanted to introduce some more states down the line, we can simply add them to the task status enum. But for the moment, we're going to have a status field of the task status type, and that's going to allow us to capture whether or not a task is open or complete. Now, some tasks are just more important than others, and we're going to capture this with a priority. Now, we're going to use an enum for this as well. Here we have our task priority enum, and we have the values of either high, medium, or low. So we're going to use the task priority type along with a field named priority to capture this information. At this point, we've captured all of the fields that were mentioned in the project brief. However, we are going to need some additional fields to make the task app work like it should. Let me ask you this. How can we currently tell one task from another? Well, they might have a different title, for example, but we're going to need something a bit more concrete than that. So we're going to need an ID field. Now we could use a numeric ID like 1, 2, 3, etc. And that has the benefit of being unique in our database. However, in our case, we're going to use a UID, or a universally unique identifier, for the type of our ID field. And the benefit of using a UID is that it's not just unique in our database, but it's unique everywhere. It's universal. Now we're almost there, and these next couple of fields aren't required. However, they do give us very useful information. I would like to know when this task was created and when it was last updated. I like to refer to these as audit fields, as they give us helpful information when we're trying to work out what's gone on inside of our app. So here I've introduced two new fields, created at and updated at, and we're going to use the instant type for these fields. Now, whereas for a due date, we just need to capture the date. For created at and updated at, we're using instant, which is going to capture the date, the time, and the time zone. And that's going to give us some additional information when we come to audit our app. And with that, we've modeled the entire app's domain. But before we get to coding, let's now explore the application's architecture. So in summary, we've explored the concept of an application's domain, and we designed the domain for the task app. How's the app built? What are its components? How do they fit together? All good questions. Let's answer them in this lesson. To begin with, we're going to start with the high-level architecture. We're then going to explore the Spring Boot application part of that architecture, and then we're going to explore the user interface part of that architecture. So let's get started and explore the high-level architecture. This is a beginner-friendly build, and it has the architecture to match. So there are two main components. We have the Spring Boot app component, and we have the user interface or UI component. So it all starts with a user. The user interacts with the user interface via their browser. The user interface interacts with the Spring Boot application via a REST API. So let's explore each component in a bit more detail. So let's now explore the Spring Boot app component of our architecture. So the focus of this build is going to be the Spring Boot app. To keep things simple, we're going to store our data in an in-memory H2 database. This is very easy to run, and it reduces the amount of infrastructure that we'll need in order to develop our application. However, bear in mind, because the H2 database is in memory, when we restart our application, we're going to lose our data, and that's expected. It's worth noting that in later Devtiro builds, we do cover using a real PostgreSQL database that will persist data between application restarts. We're going to run this Spring Boot application directly from our IDE, so from IntelliJ, and it's going to expose the REST API that the user interface will then call. And for the moment, that's all we need to know about the Spring Boot component in our high-level architecture. So let's now move on to exploring the user interface component in our architecture. So the UI component is what the user is going to interact with in their browser, and it's going to call the REST API exposed by our Spring Boot application. So here's some things to note about the user interface component. Perhaps the most important is that I've already built it for you. I've tried to make it as easy to run as possible, so you can run it as a Docker container. As we've already mentioned, users can interact with the user interface using their browser, and we'll cover all the details on how to run the user interface when we get to that point in the build. And there we have it, our high-level architecture of our user interface and our Spring Boot application. So in summary, we've explored the architecture of the task app, including the Spring Boot app component and the user interface component. We've learned that our Spring Boot application is going to expose a REST API. But what is a REST API? So here's what we have coming up in this lesson. We're going to answer the question, what is a REST API? And then we're going to explore the task app's REST API. So let's get started and answer the question, what is a REST API? An API, or an application programming interface, is a set of rules and protocols that allow different software apps to communicate with each other. Many types of API exist, and our Spring Boot application is going to expose a REST API. REST, or Representational State Transfer, is a set of conventions built on top of HTTP. And because we're using HTTP, we're going to be using this request and response pattern. In this pattern, the client is going to send a request to a server, and the server is going to provide a timely response. In the case of the task app, we say that the user interface is the client and the Spring Boot application is the server. Again, because we're using HTTP, we're going to be using HTTP features such as the HTTP verbs or methods, the headers, and also the response codes. And we'll explore each of these as we explore our REST API. So let's start with the concept of web resources. And these represent the objects in our domain that we modeled earlier. In the case of the task app, we have just a single domain object, and that's our task. So how do we represent the task in a REST API? In REST, web resources are generally represented as JSON or XML, or sometimes both. In the task app build, we're going to be using JSON. So if we take a look here, we can see the task domain object that we modeled earlier, and then we can see an example JSON representation of that same object. It's this JSON representation that our REST API will use. In REST APIs, we represent each web resource with a URL. We generally use the plural version of the noun. So in our case here, we can see the task domain object and the URL starts /tasks. But there is a bit more to this convention. We can see that the first example here represents a collection of tasks /tasks. If we want to represent a specific task, then we'll use the second representation /tasks and then the ID of that task. And here we can see an example of a UUID or UID. Now here's a key point for REST APIs. The web resources are nouns, they're things. So you won't ever find a verb, a doing word, inside of the URLs. Instead, we rely on a different mechanism for this. We rely on the HTTP verbs or methods. When a REST API client makes a request to a server, they'll specify a HTTP verb. Examples of these include get, post, put, patch, and delete. By using these HTTP verbs, it allows a client to create, read, update, and delete a web resource. You may also hear this functionality referred to as CRUD, which is an acronym for create, read, update, and delete. So let's now explore each of the HTTP verbs in a bit more detail. We use the HTTP verb get in order to read web resources. If we want to read a single task, we may use a URL like this, http get /tasks and then the ID of the task. If we want to read a collection of tasks, so get a list of tasks back from the server, we would use http get /tasks. Now a key thing to note here is by convention, we don't need to provide anything in the request body when we make a call using http get. So next we have HTTP post, and this is generally used to create web resources, so the C in CRUD. To do this, the client would generally provide a representation of the web resource to create in the request body. So we can see here a JSON example of the task that we may want to create. A key thing to note about HTTP post is by convention, the client will never specify the ID of the web resource to create. That will be the responsibility of the server. So you can see here, we haven't specified the ID of the web resource anywhere, not in the URL and not in the request body. So next we have HTTP put, and that can be used to create web resources or do something called a full update. Now you might be wondering what's the difference between HTTP put and post. Well, it all comes back to the ID. For post, the client will never specify the ID of the web resource to create. However, with put, by convention, you would always specify the ID. So for example, if you make a call, put tasks an ID, and then have the representation of a task in there, if the task doesn't exist, you may well choose to create that task with that ID. But of course, that's entirely up to you as a developer and how you implement it. This is the convention. Now you might be wondering, what's a full update? Well, let's say this task already exists. If we were to make a call, put tasks ID of that existing task, and then a representation of the task, the detail provided in the request body will completely replace whatever representation of the task inside of the app. Or put another way, it's going to fully update the existing task with the information that's been provided. And as a result, the convention is that you would provide a full representation of the web resource in the request body when you make a HTTP put call. That is, minus any fields that are fully owned and managed by the server. You'll see the request body here doesn't have the ID field, doesn't have the created at or updated at fields, because they are fully owned and managed by the server. Or put another way, the client cannot change these fields, so therefore they are not provided. So we could say that HTTP put is aligned with the C in CRUD for create, but also the U in CRUD for update. Another HTTP verb aligned with U for update is HTTP patch. Like put, the convention is that we'll specify the ID in the URL. So we have here patch, tasks, and then an ID. However, you may note that the request body is a little bit different from what we had on put. The convention for put is that we provide a full representation of the web resource. However, for patch, we provide a partial representation. That is to say, we only provide the fields that we want to update. So in this particular case, patch tasks ID with this request body would only update the title field, leaving everything else exactly how it was. And finally, we have HTTP delete. And as you may have guessed, this is about deleting a web resource. So we can see here the HTTP verb delete, tasks, and then the ID of the web resource to delete. And by convention, we don't provide anything in the request body when we make a call using HTTP delete. And again, you may have guessed this aligns with the D in CRUD for delete. Let's now take a moment to talk about response codes. These are predefined numeric codes that the server will always provide in the response in order to indicate the status of that response. As we'll see later, the specific response code will depend on the operation. However, this is the general pattern. Response codes between 200 and 300 generally mean that everything is okay, we have a success. Of course, there are variations in this range which do communicate additional information. Response codes between 300 and 400 generally mean there's been some kind of redirect. Response codes between 400 and 500 means there's been some kind of error, but it's on the client side, and it's the responsibility of the client to resolve that error. Response codes of 500 and up means there's been an error, but it's on the server side, and it's the responsibility of the server to try and resolve that error. REST API designers have a bit of leeway with how they use these response codes, but this is the convention, so it's always worth sticking to this pattern. Now, a quick note on REST API versioning, because we are going to use this in the task app build. It's considered good practice to version your REST APIs. If we look here, we can see an example of how to do that. HTTP get/tasks. This URL is not versioned. However, the ones below it are. We have get API v1 tasks and then get API v2 tasks. Now, you might wonder why we would want to do this in the first place. Well, imagine you made some breaking changes and you were using the URL without versioning. If you were to roll out those breaking changes, all of the clients that rely on your API would then have to change to update because of those breaking changes. However, if you were to use API versioning, rather than just roll out those changes straight away, you could potentially introduce a different version and run that alongside. So in this case, the old version that all of the clients currently depend on would be v1. You could roll out your breaking changes on a new URL, v2. And that gives the clients a bit of time to move from v1 to v2. Now, it's worth noting here that the version URLs have this API prefix, and that is not mandatory, but it's a bit of convention that you'll see, and it's one that we use in the task app build. So now that we know a bit more about REST APIs, let's explore the task app's REST API. The task app REST API has 4 different endpoints. We have one to create a task, we have one to list tasks, we have another one to update a task, and we have a final one to delete a task. Now, before we explore each of these endpoints, let's cover how we're going to represent errors in our REST API. Things go wrong in software all the time, and our REST API is no exception. So it pays to standardize our error responses. And that allows our clients to handle these errors gracefully. Here we can see our standardized error response. It's pretty simple. We can see the JSON object representation here it's an object with the key of error and then a string, which is the error message. And in the case of an error, our task app REST API is always going to respond in this way. That's worth noting with this, the response status codes that we're going to use are going to be between 400 and 500, depending on the type of error that we have. So let's look at our first endpoint, and this is to create a task. So this is the request to create a task. We're going to use HTTP post, and the URL is API v1 tasks. In the request body, we're going to have a representation of the task that we want to create. We can see here a title description, due date, and priority. And now for the response. We can see here an example of the response body. Note that this one includes the ID, so some additional information is there. And this is the information that the server is responsible for. Remembering, for a HTTP post, it's the responsibility of the server to determine and return the ID. As for the response codes, we're going to use HTTP 201 created, and that will indicate that a web resource has been created. Next, we have list tasks, because we'll need some way of listing out all of the tasks on the user interface. So this endpoint is going to use HTTP GET as we are reading information, and the URL is going to be API v1 tasks. No need to specify an ID here. We want the whole collection. We want all of the tasks. And because we're using HTTP GET, we don't need to provide anything in the request body. Now for the response, we can see here an example JSON response. We have a JSON array containing JSON objects, with each JSON object representing a task. As for the response codes for this one, we'll use HTTP 200 OK. So our standard success response code. Next, we have update a task, and we're going to use this endpoint for both updating things like the title and the description, but also updating the status. We'll use this endpoint to make a task complete or make that complete task open again. So here we can see a representation to update a task. We're using HTTP put, so we can see in the request body, we have a full representation of the task. As for the URL, API v1 tasks, and then the ID of the task that we wish to update. As I wanted the server to generate the IDs when we create a task, we're only using HTTP put for update here. We're relying on HTTP post to create. Here we can see an example of the response. So we have a full representation of the task that's been updated, so a JSON object being returned here, and we have our standard success response code, HTTP 200 OK. And finally, we have delete a task. So a fairly simple request to delete a task here. We're using HTTP delete, API v1 tasks, and then the ID of the task that we wish to delete. We don't need to provide anything in the request body for this call. And now we have the response. And we can see here the response body is also empty. And as for the response code, it's HTTP 204 no content to indicate that response body from the server is meant to be empty. And with that, that is all our endpoints. And this is the REST API that we're going to implement in our task app. So in summary, we've explored the concept of REST APIs and we've established the task app's REST API. Let's start development. Let's start a new project. So here's what we have coming up in this lesson. We're first going to visit the Spring Initializer, and then we're going to download the project and open it up in our IDE. So let's get started and visit the Spring Initializer. The most effective way that I know to start a new Spring Boot project is by using the Spring Initializer. The Spring Initializer is a website. You can get to it by visiting start.spring.io. And once you're there, you should see a web page that looks a bit like this. The idea is this web page allows you to specify the configuration that you want for your new Spring Boot project, and then it will generate you a starting project that you can then continue to develop. So let's get started and select some configuration then. So we're going to start with project in the top left here, and we're going to make sure that Maven is selected. We're going to be using Apache Maven as our build management tool. As for language, we're going to be using Java, so let's make sure that's selected. And now we have the Spring Boot version. This is important as different versions of Spring Boot work in subtly different ways. We want to make sure that we select version 4.0 of Spring Boot. At the moment, this is 4.0.0, but by the time you come to watch this, it might be a slightly later version. It might be 4.0.1, 4.0.2. You want to make sure that we're selecting the latest 4.0 version. Again, if you do select a different version, if you were to choose a snapshot version, or if you were to choose a different version entirely, maybe 3.5.8, for example, you can expect things to work in a subtly different way. So I highly recommend sticking with version 4.0 for this build. So with that covered, let's now go down to project metadata. So this is where we can put some data in to describe our project. So we'll start with the group. We'll go with com.devtiro. As for the artifact, let's go with task. And as for the name, let's go with the Devtiro task app. For the description, let's go with a task tracking application. And the package name of com.devtiro.task is absolutely fine. So now we get to select our packaging. We want to make sure that we select jar and not war. Jar means that everything is going to be packaged up so we can essentially just run our application by running this jar. If we were to select war, we would have to deploy our war file to a separate application container. We don't want to do that. Let's make things easy on ourselves and let's select jar. Next, we get to select our configuration format. So let's select properties rather than YAML. Properties is simpler, it's less flexible, but that's absolutely fine for this build. Now, as for Java version, I'm going to be using the latest version of Java at the time of filming, which is Java version 25. If you can, I also recommend that you use version 25 of Java for this build. If you do use a different version of Java, then you can expect things to work in subtly different ways. So if you want to follow along exactly with what I'm doing here, then I'd recommend using the same version of Java, use version 25. So now let's scroll up here, and now we get to select some dependencies. So each of these dependencies is going to solve a specific problem for us. So if we click on add dependencies, the first one that we are going to select is Spring Web. So we can find that just by searching web. We want to make sure that we select Spring Web and not Spring Reactive Web. Going into the difference between them is a bit outside of the scope of this build, but it's just worth knowing that we want Spring Web. We're going to be using this, as we can see, because it allows us to build RESTful APIs using Spring MVC, and it uses Apache Tomcat. That is the bundled application container inside of that jar that allows us to run the application just by running the jar. So we're going to select Spring Web. But that's not all, so let's click on Add Dependencies again. So the next one that we want to include is called Validation. So it's this one here. So we give this one a click. Validation is important as it allows us to add annotations to the request objects, and it allows us a nice, easy way to validate the data. We're going to be using this, so we want to make sure that we select validation. But there's a few more dependencies, so let's click on Add Dependencies, and the next one that we want is Spring Data JPA, this one here. And this is going to allow us to interact with the database by using Java objects rather than writing SQL. So we'll select this one. Okay, we have 3, we need one more, so let's click on Add Dependencies. And the last dependency that we need is going to be our database. Now we're using an in-memory H2 database. So if we search for H2, we have H2 database. If we select this one, there we go. We now have all of the dependencies that we need. We have Spring Web, we have validation, we have Spring Data JPA, and we have the H2 database. So the last step on this page then is to click on Generate. There we go, and that has generated a project for us, a zip file, and then it's downloaded it to my machine. It should have done the same thing for yours. So the next step is to unzip this zip file and then open it up in IntelliJ IDEA, our IDE. So next we're going to open the project in IntelliJ IDEA. So here we have the file that we've downloaded from the Spring Initializer. This one here is called task1 and it's a zip file. So I've moved this to somewhere on my disk, which makes sense for me. You can put this anywhere as long as it makes sense to you. Now we're going to extract all here. There we go, and that's extracted this folder here. If you're on a different operating system, you would just need to use whatever that operating system uses to unzip that file. Now we have this folder. So I'm going to double click this. And we can see inside of this, we have this task directory. I'm going to copy this, go back to my code directory where I want it to live, and I'm going to paste it. There we go. I'm going to delete the zip file, and I'm going to delete the file that was unzipped. So let's delete both of those. And now we're left with task. Now I'm going to rename task to be WIP, which means work in progress. That's a convention that I like to use, but you can name this whatever you like. So now that we have this directory available on our disk, we were to double click it, we can see it contains a whole bunch of files here. This is our starting project. So we're now going to open this up in IntelliJ IDEA. So let's open IntelliJ. So here we are in IntelliJ IDEA, and I automatically have whatever the last thing I was working on open. So this isn't the task app. We need to open that. So let's open the task app by going to this menu in the top left, and then we'll click on open. Here we go, and this will open up a modal for us where we can select the file that we want to open. So I've navigated to the directory that we just saw, so the one that contains the work in progress directory, which contains all of our project files. I'm now going to click on that and click on OK. And we'll want to open it up in this window. There we go. So we now have the project opened up inside of IntelliJ IDEA, ready for us to start development. So in summary, we use the Spring Initializer to create a new project, and we open the new project up in IntelliJ IDEA. So now that we have a brand new Spring Boot project, let's run the user interface. So here's what we have coming up in this lesson. We're first going to configure a Docker Compose environment, and then we're going to run the user interface using Docker Compose. So let's get started and configure our Docker Compose environment. So here we are back in our IDE on our task project that we just downloaded from the Spring Initializer. So the next thing that we're going to do is we're going to create a Docker Compose environment. Now, Docker Compose is perhaps the easiest way that I figured out in order to run the user interface. It does mean that you do need Docker installed on your machine though. So if you haven't got Docker installed yet, I'd recommend going over to the Docker website and going through the installation instructions to get Docker installed. Assuming you do have Docker installed, we can go ahead and we can run the user interface, and we can do it all through one file. So in the root of our project here, I'm going to create a new file, and I'll call this one docker-compose.wml for YAML. Now I'm going to just ignore that extension for the moment, and let's expand this tab. So, depending on where you're watching this video, you can get the contents of this file either from the workbook or from the lesson notes. So we'll go ahead and we can paste this in, and then we'll go through this. So here we go, we've pasted this in. Let's go through what this file actually means. So we've given our environment a name, in this case, the Devtiro build task app. Now there's going to be some services, only one. It's going to be our UI or user interface. So here we have the Docker image. So this is a Docker image that's hosted on GitHub for the user interface for the task app build. We want to make the user interface available on port 3000. And we can see here some configuration, which tells the user interface how to find our Spring Boot application, the one that we're going to be running locally on our machines. And then we have some additional configuration for Linux compatibility. And this is all that we need. So with this in play, we can now start our Docker Compose environment. And that brings us nicely onto run the user interface. There are a few different ways to run a Docker Compose environment. I'm going to show you the way that I use from the terminal. So let's click on the terminal button on the left here, and this will open up the terminal inside of IntelliJ. Now I'm running on Windows, which means I get PowerShell. If you're running on Linux or macOS, you'll get a different shell, but the command is the same. It's docker-compose up, and this will run our environment. Okay, that looks to have been a success. Not a lot of output from the user interface. If we were to open up a new tab here, and if we were to run docker ps, this should show us all the containers that are running, and we can see there is the user interface running, and it seems to be working fine. So let's now try accessing the user interface by opening up our browser. So here we are on localhost 3000, and we can see the task app user interface. Now at the moment, the user interface isn't going to do a lot because we haven't implemented our Spring Boot backend, but here it is. And when we implement each feature, we can then use it. We can test that feature in the user interface. So in summary, we created a Docker Compose YAML file, and we ran the user interface. What's the most fundamental tool that you need to know to build a Spring Boot app? I would argue it's Apache Maven. So let's learn the most important things that you need to know about Apache Maven. So here's what we have coming up in this lesson. We're first going to ask the question, what is Apache Maven? We'll then see how Maven manages dependencies. We'll also see how Maven manages, builds and tests our projects. We'll then explore the concepts of lifecycle, phases and goals before wrapping up with a demo. We'll get to see Apache Maven in action. So let's get started and ask the question, what is Apache Maven? Apache Maven is a command line tool used in countless Java projects, and perhaps the best definition that I've come across is this. It helps developers manage their projects and all the things they need to build them. So let's break this definition down, starting with dependencies. And that brings us nicely onto dependencies. As far as I'm concerned, Apache Maven is one of the best ways to manage third-party dependencies so you can use them in your app. Perhaps you need a library to make HTTP requests or to process images. There's no point in reinventing the wheel. Those libraries exist, they're out there, so you might as well use them. Apache Maven helps you manage these dependencies. In every Maven project, you have a pom.xml file. You simply declare your dependencies in this file, and Apache Maven handles the rest. Now you might be wondering, including dependencies, that sounds simple, so why not just include those dependencies manually? Well, it may sound simple until you consider this. It's not just as simple as including those dependencies, because your dependencies have dependencies, and those dependencies have dependencies. And this is something that we call transitive dependencies. So let me ask you this, how would you work out which transitive dependencies your project needs? How would you work out which versions of those transitive dependencies that your project needs? How would you work out which version to use when different dependencies declare different versions of the same dependency? Because after all, you can only use one version of each dependency. Even if you don't have answers to these questions, I think we can agree it sounds complicated, and it is. But the good news is that Apache Maven handles this for you. So let's say you have an Apache Maven project, you've included your dependencies. Now what? And that brings us on to manage, build, and test. Dependencies by themselves don't do a whole lot. You need a way of managing your project, of building it, of testing it, and packaging it up into an app that users can interact with. Apache Maven can do all of this and lots more, but here's the catch. When you use Apache Maven in your project, you must follow the Apache Maven project structure, and you must do it exactly. If you've spent more than a few minutes in a Spring Boot app, then you've already seen this project structure. You may remember it from earlier. So here are the specifics. We have source main Java, and that's where you store your Java source code. We have source main resources, and this is where you store your project configuration and other static files. Then you have source test Java, and that's where you store your Java tests. We have source test resources, and that's where you store your test configuration and static files used in your tests. And then we have the pom.xml file, and this is the Maven project configuration file that lives in the root of your project. This project structure is a requirement of Apache Maven, and therefore a requirement in a Spring Boot project. Even if you choose to use a different build tool, like Gradle for example, your project will largely still resemble this project structure. Now the good news is that the benefits of using this directory structure far outweigh the drawbacks. So let's assume you have your project set up in this way. It allows you to do things like this. You can run Maven compile, and this will compile your Java source code because Maven knows exactly where to find it. And you can run Maven test, and this will run your unit test because again, Maven knows exactly where to find them. Now these aren't the only Maven commands that you can run, there are others, and you can even add more by installing Maven plugins. Now you might be wondering, how does this all work? Well, through life cycles, phases, and goals. And that brings us on to life cycles, phases, and goals. There are three terms that you need to be aware of when you're using Apache Maven, and that's life cycles, phases, and goals. So let's explore each of them in more detail now. And let's start with the life cycle, which defines the process for building and distributing your project. Maven has three life cycles. We have default, and that defines building, testing, and sharing your project. Then we have clean, and that defines cleaning your project's temporary build files. And then we have the site lifecycle, and this defines creating your project's website. Now we're not concerned with creating a website for our project, so this is the last time that we'll hear of the site lifecycle. But we are going to be using the default and clean lifecycles in this build. Each lifecycle defines different processes, but here's the key thing to note. They are all made up of phases. Next, let's explore the concept of a phase, and this represents a stage in the lifecycle. So let's explore the phases of the default lifecycle. We have validate, and that checks if the project structure is correct. We have compile, and that converts your Java source code into bytecode. We have test, and that runs your project's tests. We have package, and that creates a distributable package like a jar file. And then we have install, and that adds the package to your local Maven repository. And then we have deploy, and that shares your package with other devs. Now we're not going to be using the install or deploy phases in this build, but we are going to be using the others. Now here's the key thing that you need to note about phases. They run in exactly this order. And if you were to run one, let's say test, it would run everything up to that one and then run it. So for example, if we were to run the phase test, it would run validate, compile, and then test. If we ran the phase of package, then it would run validate, compile, test, and then package. So that's the default lifecycle. Let's now explore the clean lifecycle. The clean lifecycle only has one phase worth mentioning, and it's also called clean. And this deletes your temporary build files. Something important to note is that if you run a Maven command that specifies a phase in both the clean and default lifecycles, the clean lifecycle will run before the default lifecycle. Now you might be wondering, how does a phase do all of these things? Well, it comes down to Maven plugins and the goals that they provide. So let's now explore the concept of a goal, which provides the feature and does the work. And the key thing to note here is that Maven plugins provide goals. Apache Maven is modular by default and has a huge ecosystem of plugins that provide goals, adding additional features to Maven. Now, some of these plugins are default, which means that you get them as soon as you have a Maven project. You don't need to install or configure anything, you just get them for free. Some examples of Maven default plugins include the Maven Clean plugin, the Maven Compiler plugin, the Maven Deploy plugin, among others. This is all quite abstract. So where does the concept of a plugin and its goals fit in with lifecycle and phases? So here's the link. We know that we have life cycles, and each life cycle has phases. Well, here's the thing. Each plugin provides goals, and the goals are bound to the phases. And you can bind more than one plugin goal to a phase. And of course, because each life cycle has multiple phases, well, you get the picture. Again, this is quite abstract, so let's look at some concrete examples. So let's take the Maven Compile plugin. The goal is called compile. The phase it is bound to is the compile phase in the default lifecycle. So when you run Maven Compile, it's going to run the phase, and as a result, it's going to run the compile plugin goal. Let's look at another example. So the Maven Clean plugin has the clean goal. It's bound to the clean phase, which is in the clean lifecycle. That's not a typo, they all have the name clean. So it's the clean goal bound to the clean phase in the clean lifecycle. So when you run Maven Clean, you're running the phase, which will run the clean plugin goal that is bound to the clean phase. Now don't worry if you don't understand this immediately, it will come in time. So let's now take a look at a demo. And that brings us on to Maven in action. So here we are in our IDE, and this is the project that we downloaded from the Spring Initializer. And we're going to be using this to demo Apache Maven. Now before we start, some things to note. I have Maven installed on this machine, but it's not a requirement for this build. I'll show you how you can use Apache Maven without having it installed, and we'll do that at the end. Another thing to note is that I'm going to be showing you how to run Maven from the command line. But in addition to that, everything that I show you that you can do from the command line, you can also do from IntelliJ by using this Maven window on the right here. For example, if we were to expand this, we can see the life cycle, we can see the phases in here, there's our plugins, and if we were to scroll down, we can see some of the plugins in there, and then their goals. So for the moment, let's minimize that, and let's open up a terminal. Let's pull this up. So I'm running on a Windows machine, so I have PowerShell here. But if you're running on a macOS or Linux machine, you'll have a different shell, but the commands will largely be the same. Now the first one that we're going to run is going to be mvn, Maven, and then compile. And this is going to compile our Java source code. Now before we run this, let's just pull the terminal down a little bit here. And we're going to take a look at the project in the left-hand panel here. Note that there isn't a target directory. We have a source directory, but not a target directory. Maven places the compiled build files in a target directory. So if we were to pull the terminal up here, let's just scroll down a bit there, and let's run Maven compile. Okay, so we have a build success, and we can see the target directory has just popped up here. If we were to expand this, go into classes, expand this, we can see Devtiro task application. This is a class file, so this is bytecode, and this is the compiled version of, if we expand source, Java, there we go, there is the source code, and there is the compiled class. So we just pull this up and take a look at the output. We can see it's building the Devtiro task app. There's the compiler plugin running, build success, just over 2 seconds. Very good. So the next thing that I'm going to show you is going to be the clean command. So let's run mvn and then clean. And this is going to clean down our temporary build files. And that's going to mean our target directory. So keep an eye on the left here for the target directory and let's run this. Okay, build success, and we can see the target directory disappears. That's cleaned our temporary build files. Now the next thing I'm going to show you is running tests. So we have a single test in this project. There it is. And it just checks that the context loads. So this should pass. Now, we're going to run mvn and then test. And I'm just going to minimize this here. And let's run mvn test. There we go. We have ourselves a build success and we can see the target directory is back. Let's just pull this up a little bit and let's go through what's happened here. So there's some test output. Let's just keep on scrolling. There we go. So we can see the Maven compiler plugin has run there. And then we have the test being compiled. And there we have the test running. There's the test output. And then right at the bottom here, we have a build success and one test is run and it passed. So here we can see the various phases being run, the compile phase run, and then the test phase run. And we can see the proof of that if we were to look in the target directory, classes, there's that compiled class once more. And we could continue on and run the various different Maven commands, but I want to show you how you can run these without having Maven installed. So if we were to minimize this, there we go. Now I want to draw your attention to a few things on the left-hand side here. We have a couple of scripts, mvnw and mvmw.cmd. And we also have this .mvn directory here. And we can see it includes a directory called wrapper. So altogether, I refer to these as the Maven wrapper. And it allows us to run Apache Maven without it being installed on our machine. Essentially, we would run the mvnw scripts as if it were Maven. Let me show you. So if we were to just pull the terminal up a bit here, let's run mvn, in fact, let's just clear that, mvnw. We can see here I'm on Windows, so I have the dot and backslash, and then we can run, let's say, clean, and then test. And if we were to execute this, there we go. We can see Maven is running. Wonderful. So we have a build success here. There's the test output. We can see clean is run. There's the compile running too. There's the test. So we've been able to run Maven using the Maven wrapper. So by using these scripts in the project. And these are scripts that the Spring Initializer puts into our skeleton project for us. And by using them, you can run Maven without having Maven installed on your machine. And now you know enough about Apache Maven to start building. So in summary, Maven is a command line tool. Maven manages dependencies, Maven manages the project build lifecycle, and Maven works through the concepts of lifecycles, phases, and plugin goals. Now that we're comfortable with Apache Maven, let's move on to Spring Boot. So here's what we have coming up in this lesson. First, we're going to ask the question, what is Spring Boot? We're then going to compare Spring Boot and Spring Framework. We're then going to cover the concept of dependency injection, then components and beans, and finally the Spring application layers. So let's get started and ask the question, what is Spring Boot? Spring Boot is a popular framework for building Java applications. But what does that mean? Well, I like to think of a framework like this. It's a chunk of code that sits on top of a language's core library and exists to solve common problems. Common problems can be things like connecting to a database or rendering web pages, building a REST API, among other things. Spring Boot is popular for a reason. It excels at solving all of these problems, but it doesn't deserve all the credit. Let me introduce you to Spring Framework. And that brings us nicely onto Spring Boot versus Spring Framework. Like all software, Spring Boot is the result of stacking multiple layers on top of each other. Each layer has a specific purpose and relies on the layers below it to fulfill that purpose. In general, as you stack more layers, you get to solve bigger, more elaborate problems. Whereas the lowest levels deal in ones and zeros, the upper levels are the websites and the applications that you and I use every day. So let's consider Spring Boot for a moment. At the lowest levels, you have the Java core library. Now, it is possible to go even further down in the stack, but we're not going to do that because we don't have the time. At the top of the stack here, we have Spring Boot, and slightly below it, we have Spring Framework. These are different things. They solve different problems. In fact, you can actually use Spring Framework without using Spring Boot, although it is a bit of a rare occurrence these days. You see, Spring Framework does a lot of the hard work that we then give Spring Boot credit for. I like to think of Spring Framework as answering this question. How can we build maintainable software efficiently? Now, I appreciate this is a bit abstract, so let's get an example. So let's say we're building a typical application. This is a web application. It stores data in a database. It exposes web pages to users, and it has lots and lots of features. So this is pretty typical stuff. But if we look at it, we've got code in there to connect to a database and render web pages. And that's before we even get onto the features. So if we don't deal with this in some kind of framework, it's very easy for this to end up as a great big ball of mud. Or put another way, a great big mess. As any great framework should, Spring Framework gives you ready-made software components. And because they are modular, it means you can include the ones that you need and ignore the ones that you don't. Now, you might be wondering, if Spring Framework deals with the ready-made software components, where does Spring Boot come in? So let's consider this application again. If we were using Spring Framework by itself without Spring Boot, we can include all of these ready-made software components, which means we can build our app a lot quicker because we don't have to build these things from scratch. Although some of that time that we've saved from not having to build these components from scratch, we now have to invest into configuring them. Traditionally, this meant great big XML configuration files. These days we use Java annotations, but it can still take a lot of time and a lot of effort. And that's where Spring Boot comes in. It automatically configures these Spring components for you using sensible defaults. This way, you only have to tweak the configuration rather than writing it all from scratch. And so Spring sits at the top of this stack. We get access to the huge ecosystem of ready-made Spring software components, and Spring Boot is going to configure them for us, so we can just include them and get on with building our application. However, we have glossed over a very important point here, which is how do we actually include those pre-made Spring software components? Well, for that, we'll need to explore the concept of dependency injection. And with that, let's move on to dependency injection. How does Spring Framework, and by extension Spring Boot, handle all of these modular Spring software components? Well, it's through a mechanism called dependency injection. Dependency injection, sometimes called the inversion of control principle, isn't a concept specific to Spring Boot. In fact, it's a more fundamental concept in software development. That said, it can be a little tricky to wrap your head around at first, so don't feel too bad if you don't get it immediately. I certainly didn't. In Java, we have the concept of abstract and concrete constructs. For example, the interface is abstract, whereas a class is concrete. The interface defines the behavior, and the class would implement it. When we write code to depend on abstractions rather than concretions, we build in flexibility. And we really want this flexibility in our applications, because like swapping out the batteries in a remote control, we can swap out these concrete classes, providing they implement the interface. And this empowers us to make isolated changes to our application rather than having to rewrite the entire thing. So let's look at an example of dependency injection in action. Let's say we have a web application that saves files. At the moment, it saves files to the file system, and it does so by this class, disk file writer. Now this application, it saves a lot of files, so we use the disk file writer class in lots of different places. And you might be wondering, how do we do that? Well, every time we need a disk file writer, in the constructor of that class, we simply use the new keyword to create a new instance of disk file writer. Here we can see an example of the report generator class. Inside of the constructor of report generator here, we have this.filewriter equals new disk file writer. We're creating a new instance of disk file writer. But wait, our application is now so popular, the disks are filling up far too quickly. And management have decided that we now need to move to cloud storage. You know what that means. Every time we're using the disk file writer class, we now need to replace it with a cloud file writer class. And because we're using the disk file writer class in loads of different places, we'll need to replace it in loads of different places. And that's not even the worst bit. Here we can see that the cloud file writer class needs cloud credentials when we create a new one. So we're having to pass in the cloud credentials to the report generator constructor. Now, if the report generator was layers and layers deep in the code base, we would have to pass the cloud credentials through loads of different classes that have nothing to do with saving files in the cloud. What we have here is a mess and it's unmaintainable, but the good news is that it's a solved problem. Rather than use the new keyword to create new instances of this class all over our code base, we're instead going to rely on an interface. In this case, the file writer interface. And here we can see an instance of file writer passed in as an argument to the report generator constructor. The file writer interface defines the behavior of writing a file. It could be to anywhere. So the report generator class doesn't need to know if it's being written to disk or written to the cloud. It only needs to know that it can write a file using this file writer. Then we can rely on Spring Framework or Spring Boot to create a new instance of this file writer. It might be a disk file writer or a cloud file writer, and then inject it everywhere that we have declared a file writer interface as an argument in a constructor. The brilliance of this approach is that we only have to create the new instance of file writer, along with its configuration if we need it, in one place, rather than all over our application. So let's see what this would look like if we were using dependency injection from the start. At the moment, we're relying on the file writer interface everywhere in our application. The implementing class that we're using is the disk file writer that writes these files to our file system. We're then informed our application is so popular, we now need to save files in the cloud. All we would have to do is, via our framework, be it Spring Framework or if we're using Spring Boot, we would swap out the disk file writer to be a cloud file writer. It would be injected everywhere that we have declared file writer, and we are now saving files to cloud storage everywhere in our application. Let's now see how this works in practice. So let's now explore the concept of components and beans. You know how we've been talking about interfaces and implementing classes? Well, Spring Framework uses a different word for implementing class. It uses the word bean. Why it uses the word bean is not important. The reason is largely historical, but the key point is this. From now on, I'm going to be using the word bean. However, if that ever becomes confusing, just pretend I'm saying implementing class. So now that we know what we mean when we say the word bean, let's look at a few ways that we can define them in a Spring Boot application. By far the easiest way to define a bean is by adding the @component annotation to the top of the implementing class. When we do this, it tells Spring a few things. It says, inject me wherever the interface that I implement is declared as a dependency. And it also says, if I have declared any dependencies, inject them so I may use them. So how do we declare a dependency? Well, we've already seen how we do that. So here we are back in our report generator class. And if we look at the constructor here, we have declared a dependency of file writer. Or put another way, in order to declare a dependency, we must specify it as an argument to the constructor. You may also note that the report generator class has the @component annotation on the top, marking this as a bean. That means anywhere that we have declared report generator as a dependency, it will be injected, and the file writer will be injected into the report generator because it's declared it as a dependency. Now it should be mentioned there are other ways to define beans in a Spring Boot application. You may want to use a configuration file, for example, or you may want to use one of the other annotations that work in a similar way to @component. However, as we already know enough to start building, we're not going to linger on these concepts any longer. That said, there is one last concept that we should explore, and that's the concept of Spring Application Layers. And that brings us very nicely onto Spring Application Layers. We've already established that the concept of layers is very important in software development. It should be no surprise that it's also important in a Spring Boot application. Broadly speaking, a Spring Boot app can be divided into 3 separate layers. We have the persistence layer, we have the service layer, and we have the presentation layer. This is an example of a layered architecture. There's nothing to say that you have to code in this way, but I strongly advise that you do. So here are the rules of coding in this way. Each layer has a specific purpose. If the code you're writing doesn't serve that purpose, it doesn't belong in that layer. And the second one is that each layer must only depend on the layers below it. So that means the presentation layer on the service layer and the service layer on the persistence layer. Let's now explore each of these layers in a bit more detail, starting with the persistence layer. The purpose of the persistence layer is to handle interactions with the persistence technology. This is often a relational database, but it doesn't have to be. However, for the sake of this, we're going to assume that it is a relational database. In which case, this is the layer where we would write our SQL queries, or we would create the Java classes to model the database tables, and we call these entities. The persistence layer is the bottom layer in a Spring Boot application, so it doesn't depend on anything, it's the one right at the bottom. So next, let's move on to the service layer. The service layer is where we code all of the application's features, the business logic. It all lives in the service layer. The service layer can use components from the persistence layer to read and write from the persistence technologies. So in our case, to read and write from the database. We've already mentioned entities once before. They're the classes that we create in our persistence layer in order to map to the database tables. If we want to, it's acceptable to return these entity objects when we call a method in the service layer. However, if you want to decouple things even further, you can use dedicated objects that you create in your service layer and never return an entity. A full deep dive into the pros and cons of each approach is a bit outside of the scope of this, but it's worth pointing out we're going to be returning entities from calls to our service layer in this build. So next, let's move on to the presentation layer. And the purpose of the presentation layer is to expose the application's data and business logic to users. And it can do that in a number of different ways, including REST APIs and web pages. In fact, it is possible for an application to have web pages and also expose a REST API. So you could think of it that an application could have more than one presentation layer, at least conceptually anyway. Now the presentation layer relies on the service layer in order to fulfill its purpose. Ideally, it should not make direct calls to the persistence layer. There's nothing to stop you from doing this, but if you want to keep things organized and decoupled, I strongly recommend that you always make calls from the presentation layer to the service layer. Now this is where things get a bit more advanced. Because an application could potentially have more than one presentation layer, for example, it could expose a REST API, it could also have web pages, I recommend that the presentation layer is where you should prioritize your decoupling efforts. Don't worry if it's not immediately obvious what that means, we'll go into an example. But in order to fully understand this, we'll need to explore a pattern first. So let me introduce you to the DTO pattern, and DTO stands for Data Transfer Objects. The DTO pattern is one way that you can decouple your presentation layer from the rest of the application. So let's see that example, let's see it in action. So let's say we have an application, it has a presentation layer, it exposes web pages to users, it has a service layer, and it has a persistence layer. Let's say after a bit of time, some additional features are added to this application, and it now exposes a REST API, and it also exposes a GraphQL API, let's just say. And let's say we were just returning the objects returned from the service layer to callers of our REST API, our GraphQL API, and maybe even web pages too. If we were to make a change to that object that's returned from the service layer, it would affect all three of these different presentation layers. It would affect the objects returned from the REST API, possibly the GraphQL API, and possibly the web pages too. Now we're talking very high level, and there's lots of ifs and buts in here. However, the danger is very real. We don't want to change things in the objects returned by our service layer, then automatically change how things are done in the presentation layer. So one way of solving this issue is to use the DTO pattern. So here we have the three layers of our Spring Boot application, the persistence layer, service layer, and presentation layer. So our layered architecture. If we were being really strict with this approach, when we called methods in our persistence layer, we would return entities. When we called methods in the service layer, we would return service layer objects. So objects that are owned by the service layer, we wouldn't return entities. And when we call the presentation layer, we would get DTOs. We wouldn't get service layer objects, and we wouldn't get entities. We would get objects owned by the presentation layer. Now it can be quite a lot of work to manage all of these different objects and all of these different layers. So it's not uncommon to be a little bit more relaxed. And what that means is that when you call methods in the service layer, it's acceptable to get entities back rather than dedicated service layer objects. Perhaps it's best practice to return dedicated service layer objects, but in reality, you often do get entities back. And therefore, this is the approach that we're using in this build because there's slightly less moving parts. It's a little bit more approachable. However, you may notice in the presentation layer, we still have those DTOs. And it may very well be different DTOs, different objects for web pages, for REST APIs, for GraphQL APIs, or any other type of way of interacting with our application via the presentation layer. So we've established the DTO pattern is a great way to decouple the presentation layer from the rest of the application. However, how do we go from these entities or service layer objects to DTOs and back again? Well, we would use mappers. Mappers are dedicated classes which do this one thing. They will accept service layer objects and entities and give you back DTOs. You can give them DTOs and they'll give you back service layer objects or entities. they'll map from one to the other. And we will be using mappers in this build. And that brings us on to the end of our whistle-stop tour of Spring Boot. Don't worry if you didn't get everything immediately, it should become a lot clearer as we build our application. So, in summary then, Spring Boot provides solutions to common problems. Spring Boot builds on top of Spring Framework. Spring Framework provides dependency injection features, and Spring applications have layers, with each layer serving a specific purpose. Let's start coding our domain in our Spring Boot application. Now we can't just start with the task class. We need to create a few enums first. So here's what we have coming up in this lesson. We're going to create the task status enum, and then we're going to create the task priority enum. So let's get started and create the task status enum. So here we are back in our IDE. Let's keep things organized. Let's create a new package inside of Devtiro task, and we'll call this package domain. And this is where we're going to keep all of our domain classes. Now, we're going to create a few enums that are going to be used in the entities used in the persistence layer. So I'm going to create a new subpackage inside of domain, and I'm going to call this one entity. As the name suggests, this is going to allow us to organize our entity classes from everything else in the application. So inside of domain entity, let's create a new Java class. And we'll call this one task status, and this will be an enum. So let's select enum, click on enter. Here we are, we have the task status enum here. Let's expand this, and now we can get to work. So a task can have two statuses. We've established that. The first one is open. So we're going to type open, all in caps, and then a comma, and the second one is complete. Again, all in caps. And this will allow us to model when a task is either open, so it's a brand new task, and when we've completed that task. Now you might be wondering, as there's only two values in this enum, can we not just use a Boolean and use true or false to model this? And yes, we absolutely can. However, if we wanted to add another status later, perhaps we'll add a status cancelled or perhaps archived. That's very difficult to do when we've used a Boolean. But if we've used an enum to model this, we can just add another status to the enum. So we're going to use the task status enum here. And now we can move on to creating the task priority enum. So we have task status, let's now create task priority. So we'll follow a similar pattern for this one. So let's open up our project. And then again, inside of domain entity, we'll create a new Java class, and we'll call this one task priority. And this will also be an enum. There we go, and let's expand this. A task can have three different priorities. It can be high priority, it can be medium priority, and it can be low priority. So we've created three different values to represent those three different priorities, high, medium, and low. And with that, we have our task priority enum ready to use. So in summary, we created the task status enum to model task status, and we created the task priority enum, and that's to model task priority. Now that we've created our two enums, we can now create our task entity. So here's what we have coming up in this lesson. We're going to start by defining our task class's instance variables. We're then going to generate constructors. We're then going to generate getter and setter methods. We're going to generate the equals and hashcode methods. And then we're going to generate the toString methods. So let's get started and define the instance variables. So here we are back in our IDE. Let's create the task entity class. So inside of domain entity, we're going to create a new Java class, and we'll call this one task, and this will be a class. There we go. And let's expand this. So this class models the task domain object inside of our application. But as it's an entity, it also models how we save that data in our database. It maps to the tasks table in our database, and we can specify all of that configuration inside of this class. So let's start by putting the @entity annotation on the top of this class, marking this as an entity. And then we're going to specify an additional annotation, this one @table, and then we'll open a set of parentheses, and inside of here we have some arguments that we can specify. We're going to specify name, and we're going to specify tasks. So here we've told Spring a few things. First of all, that this class represents an entity, so it maps to a table in our database. And with the table annotation, we've actually specified the name of the table. Now we're relying on a lot of default configuration provided by Spring Boot. So what this means is that the tasks table is going to be automatically created inside of our database. And because we specified the name tasks here, we've ensured that the table is going to be called tasks. So with that done, we can now move on to some instance variables. So the first one is going to be the ID of the task. So private UUID, because UUID is the type that we've decided on for our IDs. And we're going to call this one ID. Now, because this is the ID for our entity, we need to mark this with the @ID annotation. We also want the ID to be automatically generated for us. We don't want to have to do that inside of our business logic. So we're going to use the generated value annotation here, open up a set of parentheses, and we can see we have some arguments that we can specify. We're going to specify the strategy, and this is going to be generation type of UUID. So we'll select that, and that will generate that UUID for us. And now we're going to specify the column annotation. The column annotation, much like the table annotation, allows us to specify some additional details as to how this entity maps to the database tables. Of course, @column is our column information. So we're going to say the name of the column is going to be ID. Updatable is going to be false. We don't want this value to be updatable. And nullable is also going to be false. We don't want any null IDs for our task. So now that we've done ID, let's move on to our next instance variable. This is going to be a private string, and we'll call this one title, the title of the task. And let's add the column annotation to this one. The name is going to be title, and nullable is going to be false. We don't want any tasks in our system with a null title, but we're going to leave off updatable. Updatable defaults to true, and we want users to be able to update the title of a task. So that's it for the title. Let's move on to the next instance variable, a private string description. This is going to need a column annotation as well, where the name is description. And we're going to specify for this one a length, a maximum length of 1,000 characters. So we're going to add a constraint to our description. So we have a few more instance variables to go. So we're going to specify next the due date, private, local, date, and we'll call this one due date. We'll add the column annotation to this one, and we'll specify the name of due underscore date. That's the name of the column that we want to use. Next, we're going to specify the enums that we just created. So let's just scroll down a bit here. We're going to say private, and then we'll say task status, and we'll call this one status. Now we're going to add a few annotations to this instance variable. The first one is enumerated, this one here. And for the arguments, we can see that we can specify a value here of enum type. So enum type, and we're going to go with string. Now this means we're going to store the value of the enums as strings in the database rather than ordinals, numbers. And there's pros and cons to that, but one easy pro is that we can then look in our database and we can read these strings and know exactly what the status is. So next, let's add the column annotation. We're going to say the name is going to be status and nullable is going to be false. We always want a task to have a status. So next, let's do task priority. Private task priority. We'll call this one priority, and it will also need the enumerated annotation. Let's put that on top there. Let's just scroll down, and we'll also add the column annotation too. Column, where the name is going to be priority. Let's spell this correctly. And nullable is going to be false. We always want a task to have a priority. We're just going to default to medium priority in our business logic, but more on that later. So now let's create our audit field. So we're going to go with private, instant, and this is going to be called created. And we're going to add the column annotation to the top of this one. The name is going to be created. Updatable is going to be false. We don't want this value to be updatable. And we're going to go with nullable is false. We never want created to be null. Next, we're going to do updated. So private, instant, updated. And then we'll go with @column. The name is going to be updated. Let's just scroll down a bit here. And then we'll leave off updatable because we want to default to updatable true. We want to be able to update updated. And then we're going to specify nullable is false. We never want updated to be false. And with that, we have all of the instance variables that we're going to need for our task entity. Let's now generate some constructors. Our task entity is going to need two constructors, one which specifies no arguments and one which specifies all of the arguments. So put another way, one where we don't specify any of the instance variables that we have here, and one where we specify all of them. Now, we don't have to write this by hand. We can rely on IntelliJ to generate this for us. We can also rely on tools like Project Lombok, which generates this boilerplate code for us, but we're not using Project Lombok in this build. We're going to rely on IntelliJ to generate these for us. So let's right click inside of our task class here. Let's click on Generate, and we're going to generate a constructor. The first constructor that we're going to generate is not going to specify any instance variables. It's that no arguments constructor. So I'm going to click on select none. There we go. The no arguments constructor has now been generated. So let's repeat this process. Right click, generate, constructor. And now we're going to select everything. We can do this with Control A, and then we'll click on OK. And there we go. There is our all arguments constructor. Our entity needs both of these in order to work correctly with Spring Data JPA. Let's now generate the getter and setter methods. So now we're going to generate those getters and setters. And again, we're going to rely on IntelliJ to do this for us. So we're going to right click. We will go to generate. We'll go to getter and setter. We're going to select everything with Control A. OK. There we go. We can now see that each of our instance variables has a getter and a setter. Now to generate the equals and hashcode methods. Different equals and hashcode strategies exist, but we're going to go with a very simple one for this build. So let's right click, we'll go to generate, we'll go to equals and hashcode, we'll just go with the IntelliJ default, we'll use get class, and here is the important part. We're going to untick everything except for ID. And what this means is that ID is going to be the only thing used to calculate the equals and the hashcode. Two entities with the same ID will be considered equal. A full deep dive into the different strategies for equals and hashcode is a bit outside of the scope of this build, but this should be absolutely fine for our purposes. So we're going to make sure that only ID is selected and click on next. We'll use the default value here, ID selected, next, and then we'll select all non-null fields, use a default value, ID is not selected, and we'll click on create. There we go. We now have equals and hashcode generated for us using ID. And finally, let's generate the toString method. So all that's left is for us to generate a helpful toString method. So we're going to right click, we'll go to generate, we'll go to toString, make sure everything is selected, click on OK. And there we go. We have a nice helpful toString for our task class. So in summary, we created the task entity. An entity by itself is little good. So let's create a repository so we can use our entity to interact with the database. So here's what we have coming up in this lesson. We're going to define the task repository, and that's it. So let's get started and define the task repository. So back in our IDE, let's create a dedicated package for our repository. So let's go to Devtiro task, and in here, create a new package, and we'll call this one repository. There we go. Now this project is only going to have one repository, but in many projects you would have more than one. And this is where you would store them all, keeping them organized. So inside of repository, let's create a new Java class, and we'll call this one task repository. And this will be an interface rather than a class. And let's expand this. Now, one of the coolest things about using Spring Data JPA is that we don't have to provide implementations for our repositories. It works it out for us. So to do this, we'll need to extend JPA repository, and then we'll specify a couple of types. The first one, our entity, which in this case is the task. And the second one is the type of the ID, which is UUID. And then we're going to place the @repository annotation on the top of the repository interface. @repository, you can think of this like @component. It's actually a subclass of @component. So it will do all of the same things that @component does, but it's a bit more descriptive. It says that this is a repository. And that's pretty much all we need to do here. Now, by extending JPA repository, if we were to control click, we can see that we get all of these methods for free. Our task repository can now use things like find all. If we were to go further up the tree to list CRUD repository, we can see that we can do find all by ID, save all. If we go to CRUD repository, we can see that we get all of this CRUD functionality. Find by ID, exist by ID, count, delete, delete by ID. We get all of this for free by extending JPA repository. And believe it or not, with that, our task repository is now ready to use. So in summary, we've defined the task repository interface. We now have both the entity and the repository that we need to start implementing features. So let's start with the create task feature. So here's what we have coming up in this lesson. We're going to create the create task request class. And that's it. So let's get started and create the create task request class. Back when we were designing our application, we decided that when we create a class, we need some information. We need to know the title of that task, an optional description, we need to know the due date, and we need to know the priority of that task. Now we're about to implement our business logic in the service layer. So let's create a class to encapsulate all of that data, all of that information that we need to create a new task. And we're going to use a Java record for this because it's just a data structure. So let's go over to the project on the left-hand side here. And then we're going to, inside of domain, so not entity, because this technically isn't an entity. This is just an object that our service layer is going to use. So I'm going to click on these three dots. We'll go to appearance, and then we're going to untick compact middle packages. And what that will allow us to do, we can see it's changed here, is inside of domain, we're going to create a new Java class, and I'm going to call this one create task request, and this will be a record. There we go, and let's expand this. So this represents the request to create a new task. Let's specify the information that we need, starting with a string, and that's the title of the task, a string description, and then a local date, and that will be the due date. We just need to import local date. And then the task priority, which we'll call priority. And there we go. This is all the information that we need to create a new task. The task's title, description, due date, and priority. So in summary, we created the create task request class. So let's now write the business logic to create a new task. So here's what we have coming up in this lesson. We're going to define the create task method, and then we're going to implement that method. So let's get started and define the create task method. To paraphrase Uncle Bob, we want to code to abstractions and not to concretions. So we're going to define interfaces, and then we're going to create classes to implement those interfaces. So we're now in our service layer. So we're going to minimize this, and inside of task, let's create a new package, and we'll call this one service. And inside of service, we'll create a new Java class, and we'll call this one the task service, and this will be an interface. And let's expand this. As the name implies, the task service is responsible for tasks. So we're going to define some behavior in here, a single method to begin with, our create task method. This is going to return the task entity, the task that was created. We'll call the method create task, and it will accept the class that we just created, the create task request class, which we'll call request. So this method defines the behavior that we are to implement. It accepts a create task request object, which contains all the information we need to create a new task, and then we return the task entity, the task that was created. Now, if you wanted to take this one step further, you could, rather than returning a task entity, you could return a dedicated object that the service layer owns. For example, you could return a create task response object, which would contain all the information about the created task, but it wouldn't be the task entity. And in this way, we would have more separation between our layers. They would be a bit more decoupled, because this method wouldn't rely on returning an entity which is owned by the persistence layer. If that was a bit too abstract, don't worry. The gist of it is this. Returning a task here, absolutely fine. If we did return a dedicated object, there are some benefits to doing so. But we're going to use a task in this build, and now we can move on to implementing this method. So let's now move on to implementing the create task method. So let's go over to the project on the left-hand side here. And inside of the service package, I'm going to create a new sub-package, and we're going to call this one IMPL. And this stands for implementation. This is a convention that you'll see in quite a few code bases. It allows us to separate the implementing classes from the interfaces, and that just keeps things a bit more organized. And it's in this package that we're going to create our new class. calling it task service, IMPL, and then we'll select class. And there we go. Let's expand this. So task service impl, short for implementation, is going to implement the task service. So let's say implements task service. And now we have this red line. If we hover over the red line, we get the option to implement methods. Here we can see the create task method that we defined in our interface. Let's click on OK. And here we have a method stub for the create task method ready for us to implement. So before we go any further, let's go to the top of the task service impl class and let's add the @service annotation. The @service annotation is another one of those specialized versions of the @component annotation. It does exactly the same things. It marks the task service impl as a bean, and it will also inject any dependencies that we declare in the constructor. But it's a bit more descriptive. It says this is a service. So let's now start to think about the dependencies that we'll need to create a new task. Private final task repository, which we'll call task repository. Task repository is a dependency that we'll need because we'll need this to interact with the database and save our new task. We have a red line here because we've used the final keyword. We need to create a constructor now. So we're going to go with public task service impl, and we're going to define a single argument to this constructor, task repository. We'll call that task repository. And then inside of the constructor, this dot task repository equals task repository. There we go. So we've defined the task repository as a dependency that the task service impl class needs. Spring will be kind enough to inject this for us, and then we can use it via this instance variable. So now that we have this, let's get to implementing the create task method. So the first thing that I want to do in this method is I want to get hold of the instant. What is the time and the date right now? Because we'll need that for our audit fields. So let's say instant.now, and then we'll assign that to a variable, which we'll call now. So the now variable contains the value for the time and date right now, and we'll need that in a moment. So let's create a new task. So we'll say task equals new task, and let's use the all arguments constructor. So we need to specify all of these different arguments: ID, title, description, due date, status, priority, created, and updated. For the ID, we're going to specify null, because when we specify null, Spring Data JPA, Hibernate in this case, is going to generate that ID for us, generate a new UUID. As for the title, we can get this from request. So we'll say request.title. Description, we can also get that from request.description. Due date, again, we'll get that from request.due date. Next, we have task status. Now, every task is going to start open. We don't require a user to specify a status when they create a new task. We just assume it's open. So we'll say task status.open. Next, we have the task priority. So the task priority comes again from request.priority. And now we have the created and updated instance. And for that, we're going to use now for both. Remembering that we can't provide null to both of these, both the created and updated date is going to be exactly the same for a brand new task. So with that, we have created a new task entity using the information from request. The next thing that we're going to do is use the task repository, calling .save to save that task in the database. And then, because our method wants us to return a task and the save method also returns a task, we're going to simply return that. So here is our create task method. We accept a create task request object, which contains all the information that we need to create a new task. We create a variable to capture the time and date right now. We then create a new task using the information from the request, making sure that we specify a null ID, so that's generated for us, and we're defaulting to the task status of open. We then use our task repository, which we have injected via the constructor up here, to save this task entity and return it to the caller. And with that, we have our create task method implemented. So in summary, we've defined the task service interface, and we've defined and implemented the create task method. So we've coded the create task method in our service layer, but how do we call it from our REST API? Well, the first step is to define the REST API's requests and responses. So here's what we have coming up in this lesson. We're going to create the create task request DTO. we're going to create the task DTO. We're going to define the task mapper, and we're going to implement the task mapper. So let's get started and create the create task request DTO. So now we get to see the DTO pattern in action. So inside of the domain package here, I'm going to create a new sub package. So new package, and we'll call this one DTO. And inside of the DTO package, let's create a new Java class, and we'll call this one create task request DTO. And this will be a record. And let's expand this. So the create task request DTO is the object that the REST API is going to expect in order to create a task, in order to call our service layer. So this must include all the information that we need to create a new task. Now you might be wondering, why don't we just use the object that we already created in our service layer? Well, the reason is we created that in our service layer. The service layer owns that. We don't want changes in the service layer to change our REST API. We don't want changes in our REST API to automatically change our service layer. So we decouple them. We create a new object owned by our presentation layer. And that is this, the create task request DTO. But it does need to include all the information that the service layer expects. So we're going to need a string, and that is going to be the title of the task, a string, and that's the description of the task, a local date, and that is the due date, and then the task priority, which we'll call priority. And this would work. This would work perfectly fine. However, we're going to go one step further and add some validation annotations. And what this means is by adding these annotations, we're going to get a nice, easy way of validating the values in these variables. If that's a bit abstract, don't worry, you should see what I mean when we start adding them. So the first one that we're going to add is to title. Now, title cannot be null. I would even go as far as to say that title cannot be an empty string. So we're going to add the not blank annotation to the top of this. And we can see that's imported from Jakarta validation constraints. So this is the validation dependency that we added in the Spring initializer. And this will ensure that title is not blank. So it's not null and it's not an empty string. If it is either of those things, an exception will be thrown, but more on that later. Now, the next one that I'm going to add to this one is at length. And this allows us to specify a maximum length. We can do that with the max argument, and now we can specify a value. So the default value for our database is 255. So we're going to specify a maximum length for our title of 255 characters. This way, if the title is longer than that, we catch it in our presentation layer rather than it go all the way down to our persistence layer. Now, here's something interesting. We can actually provide a message to be returned when either of these annotations are triggered. So for example, if we find that title is blank, or if we find that the length is greater than 300 characters, we can specify the message that is returned in that exception. Let's specify the same error message for both here. And to do that, inside of these braces, I'm going to specify a constant. So let's do a private static final string, and we'll call this one error message title length. And we're going to run out of room, so let's put this on a new line. And the value for this one is going to be must be between 1 and 255 characters. And now we can use this as the error message for both not blank and also at length. So now on to description. So we know that a description can have up to 1,000 characters, and we also know that it's optional. So I'm going to add first the length annotation here, saying that max is going to be 1,000 characters. We'll specify the message for this in a moment. And I'm also going to specify the at nullable annotation, making sure we get the one from Jakarta. So let's now add the validation error message for length. And for consistency, let's do that down here in a constant. Private static final string. And we'll start that with error message so it's nice and consistent. But let's call this one description length. And again, we're going to run out of room. So let's put this on a new line. And let's say description must be less than 1,000 characters. And now we can use this up here. We'll say message equals error message description length. So now for due date. Due date can be null. It's optional. So we're going to add the nullable annotation to this one too. Let's just run a formatter because this is all over the place. That's a bit better. So we have at nullable for due date because it's optional. However, we want to make sure this due date is in the future or perhaps the present day. It doesn't make sense to have a due date in the past. So we're going to add the @future or present annotation to the top of due date. And that will make sure that the due date is either the current date or in the future. So again, the future or present allows us to add a message. So let's add a message down the bottom here, private static final string, and we'll call this one error_message due date future. And let's say due date must be in the future. And now we can use this error message up here in the future or present annotation. And finally, we have task priority. And for this one, as it's an enum, we're just going to say not null, making sure that we get the one from Jakarta validation. And again, we can specify a message in here. Let's specify it down here though. Private static final string error_message. And we'll call this one priority. And we'll say task priority must be provided. And now we can take this and place this up here in the not null annotation. And with that, we have our create task request DTO. It contains our title, description, due date, and priority. And each of the variables has validation annotations, which make sure that the values are exactly what we expect them to be. But this isn't the only DTO that we're going to need. We're also going to need something for the response. We're going to create the task DTO now. So let's go over to the project, and inside of the DTO package, create a new Java class, and we'll call this one task DTO, and we'll make this a record. And let's expand this. Now we're making a generic DTO for our response. We're going to use this on a few different endpoints. The benefit of this is that we can reuse this one object. We don't have to create many. The downside of this is that we've coupled these endpoints just a bit more. However, for this build, that's absolutely fine. So we're going to use this task DTO to model the response from creating a task and potentially other endpoints. So what does this need to include? Well, we want to know the ID of the task. So UUID, ID. We want to know the title of the task, the description of the task. We want to know the due date of the task. We want to know the task's priority. And we'll also want to know the task's status. There we go. So basically all the information about a task, but we're not including the audit fields because they're not really important to callers of the REST API. So we have here the ID, title, description, due date, priority, and status. Now you might be expecting to add some validation annotations to this DTO, just like we did for the create task request DTO, but we're not going to, because the task DTO is only ever going to be returned from the REST API, never accepted. So therefore, we don't need to validate the values in these variables. So that's it. We now have our task DTO. So let's now move on to defining the task mapper. So we've created a few different objects so far. We have a task DTO, a create task request DTO. We have if we look inside of entity here, a task entity, and we also have this create task request. So they seem to have a lot of the same information in them, but we do understand that they're owned by different layers. But we definitely need to go from one to the other. We need to map from one object to another. So we need a mapper. So we're going to create a new package so we can keep things organized. So in com Devtiro task, let's create a new package and we'll call this one mapper. Inside of mapper, we'll create a new Java class and we'll call this one task mapper. And this will be an interface. And let's expand this. So inside of the task mapper, we're going to define the mapping behavior that we want in our application. So the first one, we want to return a create task request. We're going to call this one from DTO, and it's going to accept a create task request DTO, which we'll call DTO. So we can call this method to take a create task request DTO and map that to a create task request, which is the object expected by our service layer. That's our first one. The next one is going to return a task DTO. We'll call this one to DTO, and it will accept a task entity, which we'll call task, and we'll need to import task. And there we go. So we have two methods on our task mapper. One taking a create task request DTO, mapping it to a create task request, and the other one taking a task entity, mapping it to a task DTO. And for the moment, that's all the mapping behavior that we'll need defined. So let's now move on to implementing the task mapper. So we have an interface, we now need to implement it. So let's go over to project here, and following the same convention inside of Mapper, let's create a new sub package called impl. And then we're going to create in here a new Java class called task mapper impl, and this will be a class. And if we expand this, we'll say that task mapper impl implements task mapper. We get a red underline. We go implement methods, making sure both are selected, click on OK. And now we have the method stubs ready to implement. Now, before we go any further, let's add the @component annotation to the top of this class, marking it as a bean. And now we can start implementing these two methods, starting with from DTO. So this needs a create task request returned. So we're going to return a new create task request. And if we look at the constructor here, we need a title, description, due date, and priority. We can get all of this information from the create task request DTO. So first is the title. We can go DTO title. Next is a description, DTO description, due date, DTO due date. Task priority is DTO priority. And it's as easy as that. So that's the first one done. Let's now do the second one. This needs a task DTO, return new task DTO. And for this, we need the ID, task.getID. Title is task.getTitle, task.getDescription. Due date, task.getDueDate, task.getPriority. And finally, status, task.getStatus. So each of these methods will accept an object and then map it to an object which it returns. Now these mappers might look quite simple, and that's because they are. Mappers in general are quite simple, which is why libraries like MapStruct exist to do this all for you. Now we're not using MapStruct in this build, we're going to write our mappers manually because there's value in understanding exactly what's happening here. However, if you did want to use MapStruct at a later time or in a different build, MapStruct is a great tool to know. And with that, we now have our task mapper impl class ready to use. So in summary, we created the create task request DTO class. We created the task DTO class. We defined the task mapper interface, and we implemented the task mapper interface. We now have everything that we need to start implementing our REST API. So let's create a task controller. So here's what we have coming up in this lesson. We're going to create the task controller class, and then we're going to create the create task endpoint. So let's get started and create the task controller class. So back in our IDE, we're now going to create the task controller. And this is how we implement our REST API. So inside of Devtiro task, let's create a new sub package. New package, and we'll call this one controller. There we go. And inside of controller, we're going to create a new Java class, calling this one task controller. And this is going to be a class. And let's expand this. So inside of this task controller class, we're going to create methods to represent the endpoint of our REST API. Before we can do that, we need to add some things to the task controller class. The first one is the @REST_controller annotation, marking this class as a REST controller. Or put another way, we're telling Spring to look here for the various different endpoints of our REST API. Now let's add another annotation to the top of the class. This one, the request mapping annotation. And then we're going to specify the path argument, and this will allow us to specify the base path for all endpoints in this task controller. If that's a bit abstract, it should make more sense when we say the value is /API v1 tasks. You'll likely remember this from our previous discussions in our REST API design. We're using the API prefix as our convention. We've versioned this API. We're using v1. And we're using tasks to represent the task web resource. Each method in this controller can then add their own path after this, but it will always start with API v1 tasks. So with that done then, we can now add some dependencies to our class, and we're going to need two. The first one, private final, is going to be our task service, which we'll call task service. So we need our task service to interact with the service layer. The second one, private final, is going to be our task mapper, which we'll call task mapper. And we need this to take objects owned by the presentation layer, so our DTOs, and map them to objects that we can then use to interact with our service layer. So with these both in play then, I'm going to take a shortcut here. I'm going to hover over the red lines. I'm going to go add constructor parameters, selecting both OK, and it's going to generate that constructor for me. Now, the @REST controller annotation works a bit like @component. It marks this particular class as a bean, which means that the task service and the task mapper will be injected and available to use via these instance variables. And with that, we now have everything that we need in our task controller. We can get to implementing our create task endpoint. So let's now implement the create task endpoint. So each endpoint is represented by a method. So let's create a public method. This one is going to return a response entity, and this models the response from our REST API. It does require a type, and that's going to be the type in the response body, which in this case is going to be our task DTO. We'll call this method create task, and now we can specify a few arguments. Let's put this on a new line and say create task request DTO, and we'll call this one create task request DTO. So this is the object that represents the request to create a new task, has all the information that we need. However, how are we going to get this object? Well, it's going to be provided in the body of the request. So we're going to add the request body annotation to this variable. And because the create task request DTO has validation annotations, we're going to make sure Spring looks at them by adding the @valid annotation to the create task request DTO. So we've specified a method here. We've called it create task. We expect a response entity of type task DTO to be returned. And in the request body, we have this create task request DTO object, and we are validating it with our validation annotations. Now, a request body is usually provided in only a few REST calls, typically HTTP post. So how do we specify that? Well, we'll add an annotation to the top of the method here. And we're going to say @post mapping. And that specifies HTTP post as the HTTP verb or method to use. So let's now get to implementing this method. So the first thing that we want to do is take our DTO and map it to an object that we can pass to our service layer. And for that, we're going to use our task mapper from DTO, passing in the create task request DTO. And we'll assign this to a variable, which we'll call create task request, which we can see is of type create task request. Now that we have this, we can pass it to our service layer. So we say task service dot create task, passing in our create task request. This is going to return the task entity that it created. Now we're not going to return a task entity from our REST API. We're going to instead return our DTO. So again, we'll say task mapper dot to DTO, passing in our task entity, and then we can assign that to a variable if we wish, which we'll call created task DTO. And now we can return this as a response entity. The response entity is very interesting as it allows us to control aspects of the response, such as the HTTP response code. In this case, we're going to return HTTP 201 created. So let's return a new response entity, passing in the created task DTO, making sure we get the right one. And then we can specify the HTTP status of created. And with that, we have implemented our endpoint. We've specified post mapping for HTTP post. We're returning a response entity of task DTO. We expect a create task request DTO in the request body, and we are going to validate it. We take the create task request DTO, map it to a create task request object. We pass that to our create task method in our service layer, which creates a task for us, returning it. We then take that task, map it to a task DTO, which we return inside of our response entity, specifying HTTP status created or HTTP status 201. And with that, we've implemented our create task endpoint. So in summary, we created the task controller class and we implemented the create task method. Remember we added those validation annotations and I mentioned they throw exceptions? Well, in this lesson, we'll handle those exceptions. Here's what we have coming up in this lesson. We're going to create the error DTO. We're going to create the global exception handler, and we're going to handle validation exceptions. So let's get started and create the error DTO. Remember when we designed our REST API and we said we were going to standardize the error response? Well, let's create a DTO to model that standard error response. So inside of domain here, inside of DTO, I'm going to create a new Java class, calling this one error DTO. And this will be a record rather than a class. And let's expand this. This will probably be the easiest DTO you ever make. Our standard error response is very simple. We just need to specify string error, and then our DTO is ready to use. Now let's move on to creating the global exception handler. Exceptions can happen anywhere in our class, and when they do, they bubble up. We need a way of catching those exceptions and handling them so we can give an appropriate response to callers of our REST API. The good news is that there is an established pattern for this called the global exception handler. So let's go over to project, and inside of controller here, we'll create a new Java class calling this the global exception handler, and this will be a class. And let's expand this. So it's the purpose of the global exception handler to catch the exceptions that we tell it about and then return an appropriate response to callers of our REST API. To do that, we can add the annotation controller advice. And now we can specify the exceptions that we want it to catch and handle. And now to handle the validation exceptions. So let's say public, returning a response entity of our error DTO. And we'll call this one handle validation exceptions. And the particular exception that we want to handle is the method argument not valid exception, which we'll call EX. And now we can write the logic to handle this exception, returning an appropriate response. So the first thing that I want to do is extract the validation error message from the exception. So we're going to say EX dot get binding result. And then we're going to say get field errors, which returns us a list of field error. Let's do a stream on this because I only want to get the first one. So we'll call find first, which gives us an optional of field error. Now, in the case that the field error is present, I just want to get the error message from it. So we can do it like this, x.get default message, and then that will allow us via this yellow underline, which we hover over here. We can then replace lambda with method reference, gives us this default message source resolvable get default message. But basically, this is the validation message that we need. Now, this isn't optional, so we're going to say or else, and then we'll just say validation failed, and we'll assign this to a variable, which we'll call error message. So we now have this error message. How can we use it? Well, let's now create ourselves an error DTO. So we'll say new error DTO, and this will take the error message. We can assign this to a variable, which we'll call error DTO. And now we are just to return this. Now for this particular case, I think we should return a HTTP 400 because this is an error on the client side. They've passed bad information. That's not valid. So we're going to return a new response entity, passing in the error DTO, and then we can use the HTTP status of bad request. Now we're not done yet. We need to add one more annotation to the top of this method at exception handler, specifying the exception that we want to handle, which in this case is the method argument not valid exception, like so. So we have the global exception handler, and in here we've specified how to handle method argument not valid exceptions. And we've said we want to extract the validation error message, and we want to create an error DTO and pass that to the caller with the status of HTTP 400 bad request. So in summary then, we created the error response DTO class, we created the global exception handler class, and we handled the method argument not valid exception. Now that we've implemented our first feature, let's try it out by using the user interface. So here's what we have coming up in this lesson. We're going to first start the application, and then we're going to create a new task using the user interface. So let's get started and start the application. So here we are back in our IDE. Now we're going to run our application for the first time. So let's go to the Devtiro task app application class here, double click this. This is the one that's annotated with @Spring Boot application, marking this as a Spring Boot application. We can also see it has a main method in there. We can see Spring application.run and then the Devtiro task app application class, the one that we are in. So to run our Spring Boot application, there is a few ways, but perhaps the simplest is to click the green triangle here and click on run. There we go. That seems to have started up absolutely fine. Let's just make a bit of room here. We can see, if we just scroll across, Tomcat started fine, started the Devtiro task app application. So everything seems to be running here. Let's now move on to trying this out in our user interface. So let's now try to create a task using our user interface. So here we are in our browser on localhost 3000. This is the user interface. So let's go ahead and create a task. But before we do, let's right click, go to inspect. We'll go to network, And this way we can see all of the requests being sent to our Spring Boot application. So let's click on Create Task. Now we can provide some information. Let's just scroll down a bit. So title, let's go with my first task. For description, we'll go with the very first task. For due date, let's select, let's just zoom out a bit so we can see. Let's select the 31st of December. And for priority, let's go with high. Very good. So let's just pull the network panel up a little bit and click on Create Task. We have some requests being made, one a success and one a failure. Let's see what that could mean. We don't see any tasks in our application right now, and that's expected because we haven't implemented the list task endpoint yet. However, let's look at those requests. So the first one, we get a HTTP 201 back. Let's take a look at this. So this is a post call to API v1 tasks, and we get a HTTP 201 created. In the payload here, we can see we have the description, due date, priority, status, and title that we entered in the user interface. In the response, if you scroll up, we can see that we get the title, description, due date, priority, and status, but we also have an ID. So it looks like the task has been created successfully, which is very good to see. But what about this second request? Well, let's take a look at it. We can see we get a 405 method not allowed, and this is a GET call to API v1 tasks. This is the call that's being made in order to list the tasks so they can be displayed on the user interface. And really, to test that we're creating these tasks successfully, I'd like to see them listed out. So let's move on to implementing the list task feature. So in summary, we created a task using the user interface. So we've managed to create a new task using the user interface, but we weren't able to see that task listed. So let's implement the list task feature. Here's what we have coming up in this lesson. We're first going to update the task service interface, and then we're going to implement the list tasks method. So let's get started and update the task service interface. So here we are back in our IDE. Now we need to add a new method to our service layer in order to list tasks. We already have everything that we need in the persistence layer in order to do this. So let's head over to the task service here and let's expand this. So we already have our method to create a task. Let's now specify one to list tasks. This will return a list of task, let's import list, and we'll call this one list tasks. We don't need to specify any arguments to this method. So a method list tasks to return a list of tasks. And with that, we have updated our task service. So now we can move on to implement the list tasks method. So let's implement this list tasks method then. So let's go to the implementing class, which we can get to by clicking this button here. And we have this red underline again. We hover over it. We go implement methods. Okay. We now have a method stub for list tasks. Let's remove that stub and let's start implementing this then. So we're going to call the task repository. And we're going to call find all on the task repository, which we can see returns a list of tasks. And if we were to return that, that's going to return a list of tasks for us. But we're going to go one step further. I think we should specify the order of the tasks so that older tasks are at the top and newer tasks are at the bottom. And to do that, we'll pass an argument to find all. We're going to say sort.by, and then for the direction, we'll say direction.asc for ascending. And then we're going to specify the property, which in this case is created. Oh, I've prematurely closed that parenthesis, so let's remove it from there and let's place it there. And there we go. We now have implemented find all with ordering. Here we're saying order using the created field, so the instant that the task was created, and we want results in ascending order. So that means that the tasks, the older tasks will be at the top and the newer ones, the later ones, will be at the bottom. And with that, we've implemented our list tasks method. So in summary then, we added the list task method to the task service interface, and we implemented the list tasks method. Now that the service layer is done, let's move on to implementing the list tasks endpoint. So here's what we have coming up in this lesson. We're going to implement the list task endpoint, and that's it. So let's get started and implement the list task endpoint. So we're going to add a new REST API endpoint. So let's go to the project. We'll go to controller, we'll go to task controller, and let's expand this. So here's our endpoint to create a task. Let's add a new one to list tasks. So let's go down here, scroll down a bit. We'll say public returning a response entity. This one, list of task DTO. Let's import list, and we'll call this one list tasks. We don't need to provide any arguments to this method, but we do need to add the get mapping annotation to the top of this method. We're using HTTP GET for this endpoint. So with that done then, let's call the task service dot list tasks. That will give us back a list of tasks. Let's assign that to a variable. Now we need to map this list of tasks to a list of task DTO. So let's say tasks.stream.map, and then we can call the task mapper to DTO, and then we'll say to list, and that will give us, if we assign it to a variable, we'll see a list of task DTOs, and we'll call that one task DTOs. And now that we have our list of task DTOs, we can now return a response entity. If we go return, there is a nice shortcut to returning a response entity that uses HTTP 200. We would go response entity .ok, passing in our task DTOs, and there we go. We've implemented the list task endpoint in just 3 lines. We first call the task service list task to get our list of tasks from the service layer. We then, via a stream, map the task to a task DTO. So we now have a list of task DTOs, and we then call response entity .ok to return our list of task DTOs with a HTTP 200 response code. So with that done, we can now move on to testing this out in the user interface. So in summary, we implemented the list tasks method on the task controller. So we've now implemented a create task endpoint and now a list tasks endpoint. So let's try it out in the user interface. So here's what we have coming up in this lesson. We're going to list tasks, and that's it. So let's try listing tasks in the user interface. So before we can try out our new endpoint, we need to start or restart the application. We've already seen how to start it. You can restart it by using this button up here. So let's click this, go stop and rerun. There we go, that's our application started up fine. So let's head over to the user interface. So here we are back in the user interface on localhost 3000, and I've already opened up the network panel. Here it is. So you may be wondering, where's that task that we created last time? And here's the thing, because we're using an in-memory H2 database, every time we restart the application, we lose our data, but that's expected. So now we can test both creating a task and listing a task. So let's get started. Let's create a task. Let's go with walk the dog. Rex needs a walk. The due date for this one, let's select the 31st of December, and priority, high. Now, if we click on create task, very good. Okay, so we can see already that the list appears to be working, but let's take a look at the requests now. So here's our call to create a new task, 201 created, and we can see Rex needs a walk. There's our ID. The second request, the one that was failing previously, we're now getting a HTTP 200 back. If we take a look at the response, we can see a list of objects, and this is our task. Walk the dog, Rex needs a walk. There's our ID. And we can see it's displayed right here on the user interface. So it looks like, yes, our create task endpoint is working, but also our list task endpoint is working too. So in summary, we've listed tasks using the user interface. So at this point, we can create tasks and we can list them out in the user interface. Let's now move on to updating tasks, starting with creating the objects that we need in our service layer. So here's what we have coming up in this lesson. We're going to create the update task request class. So let's get started and create this class. So here we are back in our IDE. Let's create a dedicated object to represent updating a task. So let's go over to project, and then inside of domain, we're going to create a new Java class, and we'll call this one update task request, and this will be a record. And let's expand this. So the update task request should contain all the information that can be updated on a task. This will be similar to the create task request, but not quite. So let's get started. The first thing that we'll want to include is the string title, because a user can update the title of their task. Next, the string description, then the local date, due date, then the task status, status, and then the task priority, priority. So there's one very important way that this class differs from the create task request, and it's this right here. The caller can update the status of the task. You couldn't do that when you create a task. We always assume the status is open. But through this request, a user can change the status of their class, potentially making it completed. So in summary, we created the update task request class. What happens when we try and update a task that doesn't exist? We'll need to throw an exception. So let's create that exception now. So here's what we have coming up in this lesson. We're going to create the task not found exception. So let's get started and create that exception. Trying to update a task that doesn't exist is definitely an error state. So let's create an exception to model this. So inside of Devtiro task, let's create a new package and we'll call this one exception. And inside of exception, we're going to create a new Java class, calling this one task not found exception. And this will be an exception. And let's expand this. So the implementation that IntelliJ has given us is pretty good, but I want to go one step further. I want it to be every time you create a new task not found exception, you must provide the ID of that task. So to do that, we're going to create a new instance variable here, private UUID, because we're using the UUID type as the ID. And strictly speaking, we're going to be providing this via a constructor, so we can make this final. So let's now change this constructor here. We're not passing in string message. We're going to pass in UUID ID. And inside of the braces, we're going to say this.id equals ID. Now, I think we should do a getter for this ID as well. So let's right click. Let's go generate. We'll go with getter, making sure ID selected. OK. And there's the getter for ID. Now let's do something a little bit clever. Exceptions have error messages. So let's create an error message using this ID. So for that, we're going to call super as the first thing in the constructor. Now we can see there's various arguments. We're going to use the top one, the one that's just string message. And we're going to create a string using string.format. And we're going to say task with ID and then some single quotes. And inside of there, a percentage sign, and then we'll go with S. This is the variable that we swapped out for our ID. Task with ID does not exist. And then we'll provide ID, making sure we put the semicolon there. That can all be on one line. There we go. So what we've done here then is we've created a custom task not found exception. This has a single constructor. You must pass a UUID, so the ID of the task that does not exist. We'll then go ahead and create a custom error message using that ID, calling super. So that will call the constructor of the super class. In this case, runtime exception. And then we're assigning the ID to the instance variable ID, so we can query it with get ID if we ever want to. And with that, we have our task not found exception ready to use. In summary, we created the task not found exception class. Let's now implement the update task business logic in our service layer. So here's what we have coming up in this lesson. We're going to update the task service, and we're going to implement the update task method. So let's get started and update the task service. So back in our IDE, let's open up the task service and let's expand this. So we have a method to create a task, to list tasks. We're going to add a new one now to update a task. This one returning a task, so a representation of the task after it's been updated. We'll call this one update task. And we're going to specify two arguments for this one, a UUID, and we'll call this one task ID. This is the ID of the task that we wish to update. And the second one is going to be our update task request, which we will call request. So here we go. We've defined our update task method. It requires the task ID, the ID of the task we wish to update, and then the update task request, which contains all of the information that we wish to update the task with. So let's now implement the update task method. So let's implement this method now. Let's go to the implementing class, hover over the red line, go to implement methods, OK. And now we have a method stub. Let's remove return null and let's get to implementing this. So the first thing we'll do is look up the task in the database. So we'll say task repository dot find by ID, passing in the task ID. Now, if we look at the signature of find by ID, we can see it returns an optional task. So we're going to handle the case where it is not present, where it's empty. And we're going to say or else throw, and we'll open a set of parentheses there, or else throw. But we don't want runtime exception. We want a task not found exception. And then we'll pass in the ID of the task that doesn't exist, which in this case is task ID. And we can now assign this to a variable, which we'll call task. So if we get this far, we've looked up the task in the database and we found it. If we didn't find it, then we've thrown a task not found exception. So now we can get to updating the task. So we'll say task.setTitle, request.title, task.setDescription, and we'll say request.description, task set due date, request.due date, task.setStatus, request.status, task.setPriority, request.getPriority, task.setPriority, request.priority, and now we're going to update the updated field. So we'll say task.setUpdated, and we'll say instance.now. So now that we have updated our task entity using the information from the update task request, we're just going to save that task. So let's say task repository dot save, passing it in task, and then we can return that, and we are returning the updated task. So in summary then, we are looking up the existing task using the task ID. If we don't find it, we throw a task not found exception. If we do find it, we go ahead and update all of the fields here, getting the information from the update task request here, and then save the task, returning the updated task. Now I will point out there are some additional things we could do regarding database transactions. However, we won't go into that additional detail now. This is plenty good enough for this build. So in summary then, we updated the task service interface and we implemented the update task method. So we now have a method in our service layer to update a task. Let's move on to DTOs and mappers. So here's what we have coming up in this lesson. We're going to create the update task request DTO. We're going to update the task mapper interface, and then we're going to implement the updated task mapper interface. So let's get started and create the update task request DTO. So here we are back in our IDE. Now, if we go back to the task service for a moment, and then we were to take a look at the update task request, earlier we mentioned that this differs from the create task request in one very important way. This one has task status, whereas the create task request does not. The same can be said for the DTO representation. If we were to go to project, and then go to domain, DTO, and take a look at the create task request DTO, we can see we put a lot of effort into all of these validations. The same validations would be true on the update call as well, but we would need to add one for the status. So we're going to take a shortcut here. We're going to copy the create task request DTO and then paste it into the same directory, but renaming it to be the update task request DTO, clicking on OK. And let's double click this to expand. So we have title, description, due date, priority on our new update task request DTO, along with all sorts of validation annotations that we specified previously. Let's add a new field here. In addition to task priority, we're going to add task status, and we'll call this one status. Now, as this is an enum also, we're going to add the not null annotation to the top. And now let's specify an error message. So we already have one for priority here. Task priority must be provided. Let's copy that, paste that, and then we're going to rename that to be error message status. Task status must be provided. And now we can use this in the message of the not null annotation for task status. And there we go. We now have our update task request DTO. It has all of the fields that the caller needs to provide in order to update a task, and they all have validation annotations. So let's now update the task mapper interface. So we have a new DTO, we'll need some new mapper methods. So let's go to project, let's go to the mapper package, task mapper, and expand this. So the update task endpoint is going to return a task DTO, much like the create task endpoint. So we already have the toDTO method for that. However, we do need a method to map the update task request DTO to the update task request object used in our service layer. So let's define that now. Update task request from DTO, and the argument is an update task request DTO, which we'll call DTO. So we pass in an update task request DTO and map that to an update task request object. So let's now implement the updated task mapper interface. So let's go to the implementing class, hover over the red line, go implement methods, OK, and now we have our new method stub. So let's delete that, and we're going to return a new update task request object, and then we need to pass in some arguments to the constructor. So title, DTO title, description, DTO description, DTO due date, and then priority, DTO priority. And there we go. We've implemented our from DTO method, which takes an update task request DTO and maps it to an update task request object. So in summary, we created the update task request DTO class, we updated the task mapper interface, and we implemented the new task mapper method. Let's now implement the update task endpoint. So here's what we have coming up in this lesson. We're going to implement the update task endpoint. So let's get started and implement the update task endpoint. So let's go over to project. Let's open up the controller package, task controller, and let's expand this. So there's our create task endpoint and there's our list task endpoint. Let's create a new one. So public, returning a response entity, and this is going to be of type task DTO. We'll call this one update task, and inside of the parentheses, we're going to need the update task request DTO, which we'll call update task request DTO. We'll add the request body annotation and the @valid annotation, just like we did on the create endpoint. However, this isn't the only argument that this endpoint is going to need. We're going to need to specify the ID of the task that we wish to update in the URL. How do we do that? Well, this is going to use the HTTP put method. So we'll say put mapping, and then in the parentheses here, we're going to specify path, and then we're going to say /, and then in braces, task ID. So what this means then is, if we scroll to the top here, it will be API v1 tasks, and then / task ID, where task ID is the ID of the task that we wish to update. And then inside of the parentheses of update task, we can say @path variable, and then specify UUID, and then making sure that we name this variable exactly the same thing as what we have inside of the string here, task ID. And what this means then is we've specified an endpoint, HTTP put on API v1 tasks, and then the ID of the task that we wish to update. By using this annotation here, Spring's going to be kind enough to take this value and place it inside of task ID. And then we've specified the update task request DTO, and because we've used request body, this is going to be extracted from the body of the request. So we can now get to implementing this method. So let's take this update task request DTO and then map it to the object that we can pass to our service layer. So task mapper dot from DTO, passing in the update task request DTO. And let's assign this to a variable, which we'll call update task request. Now we have everything that we need to call our service layer. So we'll say task service dot update task, passing in the task ID. So this up here, and then we'll also pass in the update task request. And then we'll assign the response to a variable. It's going to be the updated task. So this here. So now we can call the task mapper to DTO, passing in our task, and we now have a task DTO. And because we're returning the task DTO in the response body with a HTTP 200 OK, we can say return response entity dot OK, passing in the task DTO. And there we go, we've implemented the update task endpoint. So we specified put mapping for HTTP put, and then a task ID in the path. We extract the task ID and also the update task request DTO from the request body. We then map the update task request DTO to an update task request object, pass the task ID and the update task request object to the update task method in our service layer. That updates the task and returns it to us. We then take that task, map it to a DTO. So here's our task DTO, and then we can return it with a HTTP 200. So in summary, we've implemented the update task method on the task controller. Before we can test out our new update task endpoint, we need to handle the task not found exception. So here's what we have coming up in this lesson. We're going to handle the task not found exception. So let's get started and handle the task not found exception. In the last few lessons, we've introduced a new exception and we'll need to handle that. So let's go over to project, global exception handler, and let's expand this. So we're going to add a new method to the global exception handler now. Public, returning a response entity of error DTO, and we'll call this one handle task not found exception. and we'll pass in a task not found exception, which we'll call EX. And let's just scroll down a bit here. Now, before we go any further, let's add the exception handler annotation specifying the task not found exception. So now we're going to create a new error DTO, and this is going to need an error message. So the error message, I think, we'll construct before. So we're going to say ex.getID, and we'll call this one task not found ID. And then we can create our error message, which we can do as string.format. And we can say something like task with ID and then $s not found. There we go. And we'll need to pass in the task not found ID, assigning this to a variable, which we'll call error message. And then we can pass that into error DTO. We now have an error DTO, and now we can return a new response entity, passing in the error DTO, and we're going to return this with a HTTP 400 bad request. So HTTP status bad request. There we go. So we're extracting the ID of the task that was not found from the task not found exception, creating an error message, using that to create an error DTO, and then returning that with a HTTP 400 bad request. Now you might be wondering, why didn't we just get the message from the exception? And we could have, except for I try and avoid that where I can, because I don't want to leak any additional information to callers of the REST API. So I've created the error message explicitly, only using the ID of the task that was not found. But with this, we're now handling the task not found exception. So in summary, we've added handling for the task not found exception. So let's now try out our new update task endpoint in the user interface. So just like before, in order to use our new endpoint, we need to restart our application, and we are going to lose all of our data, but that's okay. So let's restart our app, stop and rerun. There we go, that's our application restarted. We're good to go. So let's head over to the user interface. So here we are back on the user interface. So let's try creating a task and then update that task. So let's create a task. We'll say walk the dog. Rex needs a walk. As for the due date, let's select the 31st of December, priority, high, and let's create that task. There we go. We can now see the walk the dog task here. So let's click on the edit button, this one here, and we now have the update task dialog here. So let's change this to be walk the fish. Frank needs a walk. The due date for this one is going to be the 28th. We'll say it's medium priority. And then the status will keep as open. I realize it says due date twice here, but this is in fact the priority. We'll get that fixed. And then we'll click on save changes. Very good. So we can see here, walk the fish, Frank needs a walk, medium priority. And then we can see here the 28th of December. So that looks to have updated. Let's take a look at network. We have a few requests. This is the one that specifies the ID of the task. This is our update request. There we are. HTTP put. Let's just pull that across a bit. HTTP put to API v1 tasks and then the ID of the task, which we can see is a UUID. And we're getting a HTTP 200 OK back. We look at the payload. Frank needs a walk, walk the fish. So that's all the information we entered in that modal, in that dialog. If we look at the response, we can see the same ID. So ending AB, ending AB. So it's updated an existing task, and there's all the new information. So it looks like our update task endpoint is working as expected. So in summary, we've updated a task using the user interface. So we can now create a task, we can list a task, and we can update a task. Let's now implement the business logic to delete a task. So here's what we have coming up in this lesson. We're going to update the task service to add the delete task method, and we're going to implement the delete task method. So let's get started and update the task service interface. So back in our IDE, let's open up the task service interface and let's expand this. So create task, list tasks, update task. We're going to add a new method to delete a task. This one is going to be a void method, so it doesn't return anything. We'll call this one delete task. And then for the single argument, it's going to be a UUID. And it's going to be the task ID, the ID of the task that we wish to delete. And that's it. We have defined our delete task method. So let's now implement the delete task method. So let's go to the implementing class, hover over the red line, go implement methods, OK, and there's our delete task method stub. The implementation for this one is going to be very straightforward. We're going to call task repository dot delete by ID, passing in the task ID. And that's it. We've implemented the delete task method. So in summary, we added the delete task method to the task service interface, and we implemented the delete task method. So let's now try out the delete task endpoint in our user interface. So here's what we have coming up in this lesson. We're going to delete a task using the user interface. So let's get started and delete that task. So just like we have been doing, let's restart our application so we can use our new endpoint. There we go, that seems to be running fine, so let's head over to the user interface. So here we are back in our user interface and our database has been cleared down. So let's go about creating a task to begin with. We'll go with walk the dog. Rex needs a walk. We'll select a due date. Let's go with the 18th this time. Priority, let's go with low priority, and let's create that task. There we go, walk the dog, Rex needs a walk. So now we're going to try and delete this task. So let's just clear down our network panel. And we're going to click on the delete button here. Are you sure you want to delete this? Yes, we are. Click on delete. Okay, so there is nothing in the list here. It's empty. So if we take a look at the network calls, here we have a HTTP delete call. Just pull that across a bit. API v1 tasks, and then the ID of the task to delete. There is, of course, nothing in the response. This is a HTTP 204 no content, but it is a success. So it looks like our delete task endpoint is working as expected. So in summary, we have deleted a task using the user interface. Congratulations, you've made it to the end of the build. Not everybody gets this far, but you did, and that is a huge accomplishment. Now, if you're looking for where to go after this, then I'd recommend checking out this video right here.